Juliana.
What?
No!
We're live in 15 minutes, so grab your coffee and we'll be back exactly at 12:15 here. Guess what? It's day 5 of our WeAreDevelopers live week. And what? Well, I'm a bit sad, but also I'm a bit happy because it means that we actually managed to give you all this content in the past 4 days. And today it's also a day filled with so much diverse content, so much coding and different things that you are excited about. So be active. Show us how much you like the WeAreDevelopers live week today by doing 2 things. Going on Slido and asking questions every speaker that is out there, giving us your comments about how you like it, how you didn't like it, what is your impression about the speaker, and just encouraging us because we need to know that you're out there watching us. And it's really appreciating, the speaker really appreciated because that means that there is some kind of feedback. Like, we cannot see your faces, we don't know if you're nodding, if you're agreeing, or if you disapprove what the speaker is talking about. So Slido is really the tool for you to help us have this conference feeling. If you're watching this on our website, wearedevelopers.com/live, you see Slido right here, and you can go ahead and already ask questions or participate in the open poll that we have right now. If you're watching this on YouTube, in the link of the description of the video, there is a link to our page, and there you can also access Slido. And if for some reason you want to access Slido from your mobile phone, you can do that on slido.com and enter the event code LIVE2020. So with this being said, actually you should be set for today's agenda because it's so much cool talks coming up. We're gonna start with front-end performance testing, then go to GraphQL, finish with deep learning, quantum computing, and conversational AI. So as you see, diversity is part of the agenda today when it comes to the topics. Here is the moment to also thank our sponsors, partners, and media partners for the whole support in the preparation and also during this week, because without them this would not be possible. And before we go into our first talk for the day, I want to remind you that there will be a short closing ceremony here in our office, so make sure you stay also after the last talk to say goodbye and celebrate with us the finishing of this week. Now, our first speaker is Jonas Kröger, Solution Architect at Platform SH. And you can actually try Platform SH for free. On our website, right above Slido, there is a small banner where you can go directly there and try what you can do with them. As they say, they are the fastest way to build a modern web application. So go ahead and try this. Jonas has a background in web development, technical product management, and he actually, I think, has a pretty cool life because he loves working remotely, and in the past 2 years he has been working from 25 different countries. I'm not sure where he is right now, but we will find this actually later. So let's give it up for Jonas and our first talk for the last day of the WeAreDevelopers Live Week.
Everybody. While I would love to be in Berlin and meet in person, the times are different this year, so we are meeting online, which is not something uncommon in my case, since I'm working remotely anyways and I'm used to remote presentations. But yeah, Berlin could have been nice. I hope I can see everyone next year. I hope you are still having a good time this week with the WeAreDevelopers Live Week, all the different online events and talks, and you have already seen a lot of them. Thanks to the WeAreDevelopers team for organizing all this. I hope we see each other next year in person. And yeah, let's get started here. So my talk is about front-end performance testing. In practice, I want to give you an overview of a couple of different things, why performance is important anyways, how it feels like in the real world, and how to integrate performance testing in your everyday workflow. So yeah, let's get this started. Who am I anyways? Hi again, my name is Jonas. I am a solutions architect at Platform SH, which is a platform as a service hosting platform. The job as a solutions architect basically means I need to make our customers successful migrating applications and websites to the cloud. I am originally from Germany, but I used to travel everywhere. Basically, I work remotely. I travel a lot. Due to the current Corona situation, that's obviously not the case. So hello from Germany still. I'm not in Berlin, but a little bit more south, but still. All right, so why do you even bother about front-end performance anyways? So the first thing to have in mind is that while you are probably sitting in front of a top-notch, expensive computer in a country that has nice internet speeds, many other people in the world don't have that luxury. So this is a map how long it takes to download an HD movie in different countries in the world based on their internet speeds. So Europe and the US obviously are fine, but if you go to Africa, if you go to South America, if you go to Southeast Asia, that could look very different. So to make your site more accessible to everybody and reach more customers basically, or more visitors to your sites, it actually makes kind of sense to improve performance specifically for those. But if you optimize your site for low internet speeds, that means the people who have high speed internet get it even faster. So it's just a win-win, right? It just makes sense. The pain is actually real. I told you already, I'm traveling a lot. So this is the world I live in. This is the world I live in. I live between, for example, Marrakesh, where Wi-Fi's are just so bad. I lived the whole month just on my 4G because Wi-Fi is just, as you can see, barely usable. And then again, on the other side of that range, there's a country like Estonia, when I was in Tallinn, where the internet speeds are just very nice, nothing to complain about really. And then since I'm back in Germany now, there is something like the German train system where you are basically offline. So this is not something that is like very artificial and to be shown on a map. This is something that you can actually experience if you travel a lot or if you go to different places in the world. And let me tell you this, it is actually hard to not get frustrated with slow sites on slow connections. And then there's another thing. We talked about internet speeds on the one side, and then there's the performance of your device. So if you work on a nice high-end phone, iPhone 8, 10, or 11, whatever you have around, Google Pixel, the latest one, that's nice, and they can process JavaScript, as an example, very fast, and it's probably all right. But as soon as you go to those average phones and maybe even though below $100 phones, performance could suck very fast because the time it takes to process all your JavaScript that you are sending down the line just takes a lot of time. And then again, if we remember which countries have low internet speeds, they are very likely to also have not the latest iPhone at hand, right? So it not only doesn't make sense to send more compressed or more optimized JavaScript down the wire, it actually makes sense to optimize executing the code as well. And then if there's no other reasons than those technical ones that to me make a lot of sense, there's always a business reason. So this is a quote from Trainline, which is like a train comparison and ticketing system. They reduced latency by 0.3 seconds. And customers spend more money, basically. So with a faster website that is loading faster, people spend more money. That's a good reason, right? The other quote that I brought with me today is that Pinterest reduced their JavaScript bundles quite significantly, and their time to active as well. What that means, we will have a look in a second. And their revenue went up pretty high. So they have more signups, they have more weekly users on those mobile devices. So this is a lot of argumentation, right? So if you want to convince your boss and he's not into technical data, just use business reasons. And for those business reasons alone, it absolutely makes sense to optimize your website to load faster, to execute faster. But how can you measure that, and what does a fast website even mean? Because we can only improve what we can also measure. So you have probably seen screens like this, the Lighthouse performance score that is embedded in Chrome these days. What is the goal here? What do those numbers mean? How do we achieve those? Let's have a look at a couple of different KPIs in terms of what happens when you load the website and how the user feels. So what you see on the top is what the user might be thinking, and on the lower part of this slide you can see a couple of KPIs explained. So it all starts with the navigation. So you type in the URL of the website and hit enter, or click the button on your phone, and the navigation begins. This is where the time to first byte comes in. So when does communication actually happen? This is the first thing to have in mind. And then there's the first paint. So there's something is happening. The user can see kind of something, at least it's loading. As a user, I know something is working. So let's see how it goes on. Then we have something like the first contentful paint, which means the user can have an actual idea of how the website could look like, or how the navigation could look like. So in this case, there's a navigation bar on top and a search input field, and there's some content that's obviously still loading. But as a user, I get an idea of what's happening there. And then we have the first meaningful paint. So the first contentful paint is just that there's something. I have an idea. The first meaningful paint goes even further and actually loads the different parts of the website. So the primary content of the website is actually visible. And as a user, I see, like, I can have a first glance on, is this actually useful? Is this the site I was looking for? Do I know how to navigate, and do I know how to use the site? And then at some point we come to the visual ready state. That means the page is nearly fully loaded. I can see all the contents element. There's nothing, I don't need to wait for everything. And now it comes to the questions, can I actually use that? So I see that it is loaded, but can I interact with the site? And this is also an important KPI, the time to interactive. That means everything is loaded and you can actually use the site. You can scroll, you can click buttons. And fully loaded obviously is when everything is 100% ready. So this is more like of how do those KPIs translate into your real life browsing experience for your users. And then there's the speed index, which is also an important KPI when you want to compare different sites. The speed index basically means the average of your visual components and how fast they load. And this is this is a good KPI to compare different websites or different states of your own website. So what is the goal? And of course, those numbers could be different for your use case. They are very aggressive, but this is probably a lower baseline to start off, and then depending on your use case, set a couple of different goals for your specific site. First of all, there's how much JavaScript do you actually send down in terms of how big is the package. Of course, we are talking minified and compressed sites. Then we have the time to interactive. It should be below or well below 5 seconds. So the user doesn't get distracted. They know that there's something happening, and they have a good feeling about the speed of your site. And all that goes into is not only the site that you are sending, there goes into the bandwidth that the user has, for example. So it's not something that you can fully control. So that means your site has to just take the least amount possible of that whole time to interactive. And then there's the speed index. Like I said, this is more like a relative comparison. So your index should obviously be better than your direct competition. So check out different websites in your area and compare that with your score, and you should aim to be better than that. And then there's a time to first byte, which should be or is ideally below 500 milliseconds. That means it doesn't take too long for your server to render out the site. And also there's not too much to load in the first place. So this is something that you can set up as a goal. Like I said, there might be options on how you do that for your specific site. All right, let's come to actual performance testing. There are different types of performance testing that we can do. So there's proactive, reactive, and passive. Proactive performance testing is targeted to engineers who can use it during development. So that means you can check out your code on your local machine during development and basically make improvements before you push anything or see how the website behaves under different conditions. How you can do that is with different developer tools that are built into your browsers or other local tooling. We will check out an example for each of those after that. Then we have reactive performance testing, which is targeted to engineers and also product owners. And you can basically execute different tests, ideally automatically with every build of your website, of your application. And that gives you an idea of how your different KPIs develop over time. So if the latest feature that you developed or the latest JavaScript library that you imported, how does it affect the overall performance of your site? Maybe set up a couple of budgets and say, like, is my site over or under that budget on a regular basis? And this is not also interesting for engineers. It could be very much interesting for the product owners as well to track that and to make sure that you follow your own goals. And then there's passive performance testing, which is targeted to engineers, product owners, and now also other departments like marketing come in. And this is something you should actually do constantly with external tools checking the website. So that means when your website is live and people make changes, right? For example, marketing puts in a dozen of external tracker snippets that they copy and pasted from somewhere. This definitely impacts your site, so you want to be aware of that, even if it's not a direct impact from your code, but from, like, for example, external sources or different changes that are happening, or editors are uploading a very large file. That could also be a case. And there's tooling for that, like your Google Analytics or different others, and we will have a look at those as well. All right, let's dive into each of those and have a look on how they behave and how you can integrate all that into your daily development workflow. All right, so on the proactive side, I brought two examples. One is using the DevTools that is just integrated with every browser, and you can basically implement right now after this talk. And then there is a tool to track your different package sizes. So let's jump in and actually have a look how that can be used. So first of all, there is we have this beautiful little demo application, which is just a nice to-do application. So this is running on my local machine in a Docker environment that I set up. And obviously, if I load that from localhost, it loads very fast and everything is visible right there. So development is nice, I can debug very fastly. But how does the site feel with a not so ideal connection, right? There's something built into Chrome DevTools, for example. When you go to the Network tab, you can actually change the speed of your connection. You can emulate how the website behaves under different connections. You could use those presets, which is a fast 3G or a slow 3G, or you could also add some custom profile like a low latency behavior or a fast 4G or an edge connection, something like that. Let's use the slow 3G, for example. So I've set that to slow 3G, so it will throttle the connection and emulate how the site behaves. If I reload the site now, you can see that it takes quite a bit longer, obviously, until the site is loading. So this is how the site would feel on your slow 3G connection. And you probably already get frustrated because it's taking so long. So you can see which parts are loading, how fast they are, which assets take the most time. So it's still loading my very large vendor file. So this is something to have in mind and to make sure that you can actually test under more realistic conditions, even on your local machine. Of course, this is a development setup, so you could use the production build for that as well if you run that on your local machine. All right, this is very nice because it doesn't cost you anything. You have everything right here in your development tools already. The second tool is about the different bundles that you add to your external dependencies. So for example, if you use NPM, there's a Webpack bundle analyzer, and if you also use Webpack, that's very, very nice, because what it gives you is with every build, you get a graphic like this and a report like this, and this will show you how big the impact of different modules is that you're loading. So what we can see here is that I imported the whole Lodash library, and this is taking up a huge space compared to what else I'm doing on my application. So my vendor, obviously, and this is a Vue.js application that I used, by the way. So my vendor takes up a lot of space naturally because my application is just small and the custom code is not so much. But on that vendor side, we have the whole Vue runtime that I obviously need. But there's also this huge Lodash component that is probably good to look into how that can be removed or if I really need that. And we will have a look on how that looks later on. And basically, this is just an NPM package that you can include. I think with the latest Vue CLI, it is even included already. But even if it's not, it's easy to add. It doesn't cost much. And it's a good thing to look into. Because sometimes you import, this little helper that you found and makes your code a little bit nicer, but in the end, it's just a huge dependency that takes a lot of time to load and to process. All right, let's go back to the presentation. And now we're coming to reactive performance testing. So 2 examples that I brought today are about consumption and budgets, and about automated tests. So consumption and budget means those KPIs that we already seen, you set your own targets and you implement that in your workflow to make sure you're actually meeting those goals. And of course, automated tests make sure that those KPIs are generated with every build. So let's have a look. We will have a look at 2 different tools that you can use for that. One is Lighthouse, and the other is the web page test. So both give you an idea of different KPIs that you can track. You can see here there's the first contentful paint, there's the time to interactive, and a lot more KPIs that you can get, not only for performance, but also for other categories, as you might know. And web page test is actually also quite nice because you can execute a test that is run remotely on an AWS machine in Ireland, for example, against your website. So let's see how that actually looks. I will obviously use Platform SH for that, and Platform SH has the nice capability of hooks that I can use to trigger different tests. So what I did here is on a post deployment. I trigger a couple of different tests. One is the Lighthouse test and the other is the web page test. So after every deployment that I'm doing on any branch, I am actually triggering those tests. And this is of course Platform SH, but you could use any other CI tooling for that. You don't obviously have to use Platform SH, but Platform SH makes it a lot easier, because one of the nice features actually is that you can just spun up a new branch, which is my perf matters branch in this case, as a copy of my production environment. So I get all the data and everything from production, and I have my own domain that I can test against on that matter. So I can use that to test my site. And what I did is I have deployed and created that branch already, so we can have a look. So in this case, it will run all those different tests after the site is deployed, and it will give me a Lighthouse score. It will give me the load time and a couple of different KPIs that I'm checking here. So I can later on use that as a baseline and basically compare how my changes work against the previous deployment. So let's do that. So first things first, we talked about consumption and budgets. So there's a Webpack configuration that you can use to not only give you warnings or even errors about if you hit several thresholds. So this is this part. And basically what I'm saying here is if my asset size is more than 100 kilobytes, I want to get a warning. You could be even more aggressive and lower that, or you could be more aggressive and actually return an error, so your build fails if you don't meet those size thresholds that you have. So let's run a first build. So we run the build command on npm. So I'm basically creating the production assets of my Vue.js application. I'm doing that locally, but obviously that could be something that you could also integrate in your whole CI pipeline. And this is the warning that I mentioned. So this will give me an information if one or more of my assets are exceeding those limits that I set in that configuration. So in this case, I'm seeing that my vendor file is already very, very huge. And we know that from before because we already looked at that. So one of the other things that you can do with Vue.js or with Webpack in general is you can split the chunks. Splitting chunks means you split your JavaScript from one big file into multiple smaller ones. So it depends on your application if that makes sense or not, and how to set up those options, what the minimum and the maximum size should be. The defaults are pretty much all right, but of course you can modify that if you want. That means instead of this huge one single JS file, my build would create different ones that could be smaller in size. They don't have to be, obviously, you will see. And this is good for if you have like large applications with multiple views, where you only want to load the JavaScript that you need, that your users actually need in terms of what views they go to. So instead of one big file, I'm getting smaller ones and they are chunked up. But they are still, the combination of all those is still very, very high. And this is due to our Lodash dependency, as we know. So let's change that finally. And we can go and have a look where I use Lodash. So in this case, this is the app, the view that I used that. I'm importing the total of Lodash just for using this little sort function. But instead of loading that, of using Lodash for that, maybe there's a nicer way. So let's remove Lodash and just add vanilla.js, a vanilla.js function in here that is used to sort my array. So I could switch that code here, and you don't use Lodash anymore, but use my vanilla.js function and change that. So without that, I don't actually need Lodash anymore. So I don't have to load that. It's not getting integrated into my whole dependency graph. So let's see how that behaves. I will actually use that to and add that to my Git repository and commit that, so I can see how the different changes that I made influence the performance and influence the KPIs. So performance update, let's call it that. And then I will actually push that to Platform SH. And what Platform SH will do is it will deploy the latest code that I have. Since I'm not working on the master branch, it will use the existing perf matters environment. So I can run all the different tests and compare them to my previous runs and my previous builds, even before I push anything to production. So it will, of course, do the build of the containers, so all the NPM dependencies installations will happen, and then it will create my production build with my latest settings of chunking those files. So this is what I meant with the warning and the error. You could actually set that to an error, and that build would completely fail if you don't meet your own goals, which is very aggressive, but of course could be a nice use case. And then it's deploying the application to its own domain. So I still have that for all the testing that I can do. And after that is finished, it will run let's jump back into the configuration. It will run all the different post-deployment triggers that I implemented, which is the Lighthouse test and the web page test. For the Lighthouse test, we actually use a headless Chrome that is running, which is one of the services that Platform SH offers. And so you are not dependent on anything externally. And for the web page test, we are using the webpagetest.org API, which you can get access to for free if you need not more than 200 API calls a day. So if you get, that should be, for many cases, that should be enough. And of course, you can get more if you pay or host your own solution. So you need that API key, obviously. And what it does over here is it is executing the web page test and it's returning all those KPIs. So I can actually use that and see how the impact is. There I can see that my speed index is a little bit lower than before. And I can use that data and do anything with it. You can store that for historic purposes to see how your website improved over time. But basically, with every Git push, even on development environment, you get the different KPIs and compare that to your previous run. And since we all know that automation is the only way to achieve consistency in that case, you should definitely try to include that in your workflow and not have that run manually. Let's jump back into the slides for a couple of minutes. So yeah, this is basically a nice integration in your workflow. For passive front-end performance testing, you could use external tools to get insights on real-time usage, and you should and could also use constant monitoring also from an external service. So for the first one, the real-time users, you could use New Relic, even Google Analytics does some basic KPIs for that. If you integrate the new analytics tooling, you get an actually insight how the site feels for your users, how the data is for the actual usage. The downside on that is that you need to add a external dependency for the New Relic JavaScript snippet. So this is something that you have to weigh against each other. What you get here is basically seeing how much time your actual users from different locations in the world get. You can filter that and see how the site feels for users from India compared to users in Germany or something like that. Another tool that I really like is Calibre. Calibre is basically a kind of lighthouse as a service if you want to, but with a nice UI. And it can trigger the generation of those KPIs. Not only can you trigger that using the API on every build, you could also run that every couple of hours or once a day. And then you get a nice history of how your website behaves. With the API, you could tag your deployments and get a connection between the Calibre results and the different deployments that you're doing, for example, based on your Git hash. So what we see on this graph, for example, at least a little bit, is that obviously here something happened with the performance, with the speed index, or the performance score in general. So it went down a little bit, and this is when one of my deployments happened. So I could check if that goes up or if that goes down after one of my deployments and check that with the actual Git hash and the Git history that I've done. So I see how my code changed the performance. And you could also set up budgets in terms of those regular checks. You can set up a budget and that you want to get a notification if the site suddenly runs over those budgets. So if your marketing adds a couple of additional JavaScript snippets from Google Ad Manager and they impact the site badly and the load takes a lot of a huge spike and takes a lot longer, you would get a notification that you can check out the site and see what happened. So this is very useful also. Okay, let's come to a couple of takeaways. I think, and I hope I could convince you that performance is, even if it's an older topic, it is still super important. It makes sense to collect data to follow the change of your different KPIs. And this can only work if you implement some kind of automated tooling in your everyday workflow, because you don't want to spend too much time on collecting those APIs. You don't want to rely on developers or your team in general to run those manually. So you should just, automate all the things. I don't know if Facebook is still doing it and if some of you have heard of 2G Tuesdays, but at some point in time, a couple of years ago at least, Facebook forced the network bandwidth of some of their teams every Tuesday to a 2G level. That means they could only use basically a forced 2G connection to use the Facebook app. And by that, the developers experienced how bad their application loaded or their different new features loaded on a 2G connections. And it encouraged them a lot to actually improve performance. So this could also be like a nice thing to do every once in a while, to actually browse the site with a lower bandwidth to see the impacts and how it actually feels for your end users as well. And trust me, there are some end users who are experiencing that, whether they're on a train in Germany, whether they are in Morocco, or whether they just have bad connection somewhere. So that it will definitely happen. All right, time for a little Q&A. Before we jump into that, maybe a mention of other events that we are doing on Platform SH, if you're interested in that. One is actually happening today, this Friday, later this afternoon. my colleague Rob and his team are doing a podcast every week, and this week we are talking about extending the Platform SH platform. So we have a couple of guests from clients of ours that use platform and extended the functionality. And then there's also something next week about single and multi-site search using Melisearch, which is a search solution that you could host on your own, and you can integrate different sources from multiple sites on that. So those could be quite interesting. Please feel free to check that out and join me on that. And yeah, now I take that over for Q&A.
So Jonas, thank you very much for the presentation. It's very nice that you're our first speaker of the day, of the last day of the WeAreDevelopers Congress. I think we are starting very strong with your topic. How are you feeling? How are you today?
Yeah, I'm good. Thank you very much for having me. It's quite fun.
Perfect. Actually, Slido has been quite active already from the beginning of your presentation. So I'm going to go ahead and share my screen so we can look at the questions. Meanwhile, I do encourage everybody as well, if you want to join the discussion, go on slido.com with the code LIVE2020. You can submit your questions. The first, it's more like a comment, as we have a very nice partnership with Platform SH, is actually a comment from us that everybody can now try it for free if they click on this link. So I'm going to leave it up there, but let's go to the first question. I also just want to remind people, you can upvote the questions. So if you see interesting questions, upvote it so we can go through the most upvoted questions first. So Ignacio is asking, what about CSS performance tests goals?
Yeah, I think there's another question also about a similar topic in the chat about the critical path. So yes, CSS performance is still a thing. The critical path is also still a thing. What Lighthouse, for example, offers you, I only showed you a couple of those KPIs that they give you, but the reality is they have like a large JSON blob that you can analyze, and all the important CSS KPIs are there as well, and you can get them from there.
Okay, thank you. This comment came in the beginning of your presentation. I can relate to the train Wi-Fi thing.
I think there are many people who can.
I'm surprised seeing Germany doing that well on that map. It always felt way worse.
Yeah, I think it really depends where you are in Germany, right?
Good. Here is another encouraging comment. Great presentation.
Thank you.
Thank you, Coder. And a question. What is the best way to optimize the runtime of front-end code?
Yeah, I think there are a couple of options to analyze that as well. So one is avoid common pitfalls like using set timeout functions. The other thing is that maybe you want to push complex functions, complex things into a worker, which is nowadays has very good support across browsers. In most dev tools, definitely in Chrome, there's also a profiler that you can run to actually analyze that in even more depth.
Good. Thank you for your answer. Then, yeah, this was the question that you mentioned that was related to the CSS question. I don't know if there's something you want to add here about the critical.
No, like I said, the critical path is one of the things that is still important, and is still something that you can get out of the Lighthouse results, definitely.
Good. So Diego, you got your answer already. This is, yeah, at some point when you, I think, start showing the code, this comment came in. Tom, good morning, Tom. Tom has been a really active participant of the whole week. In your opinion, which framework will have the most future and why? Do you think a framework is always necessary?
So I think it's a difficult question because, frameworks come and go. React and Vue are both very strong. React because it has like a wide user range, and when people start nowadays, they probably learn React before they actually learn vanilla JavaScript sometimes. So it's probably here to stay for a while. Vue.js might be the one that is the most upcoming from what I see, because it's new, it's exciting. But in the end, and this goes to your second question, I don't think a framework is always necessary. The most sense of using a framework is, or the most value you get from using a framework is when you work with a lot of people on large applications, I think. The smaller they are, the smaller the teams are, maybe, or if you work on that alone, it really depends what value you get compared to the pitfalls that you can run into or the overhead you have by loading the framework in your application.
Good, Tom, I hope you got your answer. Another participant is asking us, or asking you actually, how would be the effect if you import a single function of Lodash, for example, import sort from Lodash?
Yeah, that probably has a similar effect than what I was showing in the demo. The demo was just to show one way of streamlining your code, but if you use more complex functions or something that is not available in that easy way in vanilla JavaScript, it's probably definitely a good idea to import only those parts that you actually use. The nice thing with the methodology that I used is you can check the impact by just pushing it and measuring again and see how the difference is in terms of the KPIs, and maybe even for larger functions on the actual load of your site. So I encourage you to test that out, absolutely.
Thank you. Mike is asking, can we also do those steps with platform message?
So, of course, we have some parameters that allow you to do like a proper load test of your site. Those are documented on our website. So docs.platform.sh has that for load tests. Of course, anything that brings down our whole infrastructure is not something that we would allow. If you want to go deeper into that, feel free to check out the documentation, and if that's enough, that's fine. But if not, just reach out to me and we can have a look on your specific use case, and maybe we can accommodate it.
Good. So here, because you asked, told Mike that he can reach out to you. Also, I want to mention that we have a Slack channel. If you cannot find Jonas, contact directly or something, also go in the Slack channel. It's WeAreDevelopers Live. We are there, so you can talk also directly to us, and we'll make sure we connect with Jonas. Also, Jonas, will you be sharing your slides with the attendees?
Yeah, sure. We can do that, absolutely.
So perfect. We can also, you'll find the slides also in our Slack channel. A very common question, tabs or spaces?
Spaces.
Spaces. Any reason why? How the preference came?
This goes into like a religious discussion. We shouldn't do that here, right?
we did have a poll in the past days during one of the breaks asking these questions, and it was furious. All the time was percentages. They were really close to each other, and then we also gave the options of both.
Nice.
So, this was there as well. There were people who voted.
It has to be. It makes absolutely sense.
Yeah. Good. Another question just came in. Was going to be necessity in the near future? Frameworks written in WASP seems a good idea.
If it's really going to be a necessity, I'm not 100% sure. Will there be use cases that definitely get a lot of value and get a lot of performance from using it? Yes.
Okay, loud and clear. So then we have a couple of comments. Great presentation, clear to the point. Thank you, it was a great presentation. Use tabs that get converted to spaces. I guess that just came in on the last questions. I'm gonna give a couple of more seconds if somebody else has a question, as we do have still some time before we go into a break. And just to remind you that also after we finish the session, there will be a short feedback survey for Jonas' presentation. So make sure you give us your input so we know and he knows if you like the content, so we can also do more sessions together in the future. Anything coming up? Let's see. No, but if anything comes up last second after I actually close this, because it has happened, we'll make sure we forward the questions to Jonas. So we'll find a way to get the answers. Yeah, I think if there is nothing coming up right now, I'm going to stop sharing my screen. You'll be seeing the feedback already. Actually, it's already on Slido, so you can give your opinion. Jonas, thank you so much for opening the 5th day of the WeAreDevelopers Live Week. And I hope to see you soon, if not in an online format, then one of our physical events.
Definitely next year. Thank you, everybody, for joining in. Have a great rest of the day. Enjoy the other talks and stay healthy.
Thank you. Have a good day as well.
Bye-bye.
everybody, me again, the moderator of the WeAreDevelopers Live Week. I actually did not remind you what's my name in the morning, and as I like to be really friendly with everybody, I just want to tell you, I'm Vilana. So you can also send comments on Slack or on Slido to me, how you like the moderation, how I present the speakers, just let me know if you have any feedback, because I do want to do this for a living later. So, with this being said, we're actually ready to welcome our second speaker of the for the last day of the WeAreDevelopers Live Week, Uri Goldshtein. He has been already at one of our events, and it's very nice to have him here joining us live in our virtual conference. Well, as you may already know, we were supposed to have our real physical event happening yesterday and today in Berlin. But, well, we had to adapt, and that's why we decided to do a whole week of talks instead of 2 days. So who's Uri? Uri is the founder of The Guild, a group of open source developers working around the world to help create important open source libraries, mostly around GraphQL. And that's why I think he is the best person, or the perfect person, to tell us why GraphQL between series is the best and the worst idea at the same time. Give a warm welcome of virtual applause to Uri. So, hi Uri, how are you? Hope you're doing good.
Hi, I'm good. How are you?
I'm also very fine, as you see, trying to wake up everybody for the last day. Although it's already 1:30, the weather in Vienna is super grayish, so I do feel kind of it's still in the morning. But I'm sure everybody's really excited for your talk, and that they'll be active on Slido. I already briefed them that they should ask you questions all the time, and I keep emphasizing throughout the whole week how important this is, because it's the way for you to know that they're listening, that they're there. Uri will most likely check also Slido throughout the talk, so really make sure you send some comments that you're listening, and at the end of his presentation we'll be looking at the questions. So you can go ahead, share your screen, and the stage is yours.
Thank you very much. Hi, everyone. Yeah, ask questions as much as you can. I hope that, I really hope that, my goal here is to present you an idea, but then mostly hear about you and answer your questions for as long as I can. So start asking them as I speak, and that I would know when to stop and when to go to your questions. So thanks. So I'll share my screen. Okay. So my name is Uri, and I'm the founder of a group called The Guild. We do a lot of open source. We do a lot of open source in the GraphQL world and in general. We build a lot of famous tools that you might have heard of, about the GraphQL code generator, GraphQL inspector, that helps you with everything you need in production when you get your GraphQL APIs into production. GraphQL CLI that helps you with the workflows when you work with GraphQL, and GraphQL modules, which helps you kind of build a workflow between different teams. How do you separate different teams and responsibilities and things like that. And maybe the last important library that I would mention is GraphQL Tools, which is an extremely powerful library and popular library in the GraphQL world. And it wasn't created by us, it was created by Apollo, but it was kind of deserted for a couple of years, and we took over, we rebuilt it, and we kind of brought schema stitching back, improved it, and just released the new version 6, actually 2 weeks ago. and yeah, so we're kind of like making sure the whole open source ecosystem keeps being maintained and keeps being up to date. And we have a lot of different libraries in the GraphQL ecosystems, as you can see. And the goal is because we basically see GraphQL as like a new way of looking at data, and we think it can affect the whole stack. But we also want you to just be able to gradually adopt it, like whether you're coming from the client or you're coming from the backend, we want you to just be able to use those tools like tool by tool. And we don't want you to like have to buy into the whole platform. But when we build those tools, we do look at the big picture, and we do look at like which library can help in which place. And also, you know, it looks like we have a lot of tools, but the truth is we're not trying to have a lot of tools. Like if there will be other people that would help us or they would invent those tools, we would happily help them and contribute to them. We join in where we see there's a lack or there's a need. Yeah, so if you have ideas and you want our support, please feel free, we'll support you. All of our libraries are not under the guild's name, they're under specific people's names. And it's kind of a philosophy of open source that maybe you can ask about later as well. But today I want to talk with you about the new library that we just created. It's called GraphQL Mesh. We've been using it in production for a couple of months now, and it's been out now, I think, around 2 months or something like that. And the community, it made a lot of noise, more noise than we even expected. And for us, it was very helpful. And I'll explain why. So maybe before that, I'll give a very short intro about GraphQL itself. So GraphQL is a query language. And what do I mean by query language? It means that, first of all, I can describe the data that I want to consume with a schema. And by saying data that I want to consume, it can be any data. So it can be data coming from REST APIs or other remote APIs. It can be data that comes from a database or from a file or from a memory. It doesn't matter. I can just describe any data source with a schema. And by doing that, what I can do then with GraphQL is that I can query for what I want. So as you can see here, I describe my data as a project. And then if I want to query the project tagline, I just get the project tagline, and I know exactly also what type that tagline would be, because I know the typings. So let's look at a bit deeper. So just by describing the data and with small functions that called resolvers of how to fetch the data, then I basically got this magical GraphQL engine, which is not magical at all, and maybe I'll explain about it later. But what then I can do from the client, I can ask for, let's say, user with ID 2 and just the user's name. So the client will send one request to the GraphQL engine. The GraphQL engine will fetch the user, will extract the name, and then we'll send back a response that looks exactly like what the client asked for. Now, if I want more than just the name, I want the messages, and for each message, I want the content, then the GraphQL will go in, fetch the user, then in parallel, we'll fetch the name and the messages of the user, and then it will go on and fetch for each message the content. And the content maybe comes from a third-party API. Maybe it's not at all comes from the same server, but the client doesn't care. The client got one response that exactly like we were expected to get it. And in most cases, what we see is that between the client and the server and the GraphQL engine, there's a network layer. So it means that in terms of performance, we're sending much less data over the network. The client can be much thinner, and that's nice. So that's basically like a very short introduction of how GraphQL works. Now, the thing is, when we describe the schema, we also describe basically in very small functions called resolvers how to fetch each of those fields. In that case, the user's name. So just by writing the schema, we know we need to write a function that needs to get a user and needs to do something and maybe call a server, and then needs to return a string that is equal to the name. So that's also a very nice way to divide tasks between teams and things like that. If you know GraphQL already, you understand that this is the resolvers part. Now, what GraphQL actually does, like if we look under the hood of, I said the GraphQL is not really so magical. Like what we see on this slide, we're going to see on this slide is basically how GraphQL actually works under the hood. And what it does with all the information that we provided. So we just described the schema and we described those small functions called resolvers. What GraphQL would then do, when GraphQL will get the query, the get user query, and we want the name of the user, and for each message we want the title and the date. GraphQL itself, like everything we're going to see in this slide, is basically done automatically for us. GraphQL is going to get the first box, going to send the ID into, and get back the user. Then what GraphQL is going to do is it's going to get and grab the boxes that we wanted, the name and the messages, and it's going to put in each of them, it's going to execute them with the user that we got. In the name resolver, we got the name, and that's all we want, so we can put it in the results. But for messages, we actually got 3 messages. So now, for each of those messages, GraphQL will run them all in parallel. We'll get the name of the title and the date of each of them, get the results, and put them in the right place. So everything you saw in this slide, GraphQL does automatically for you, all the orchestration and all that part, which is very powerful and saves a lot of the manual code that you do today, maybe on the client, maybe on other consumers. So it's very powerful. Now, if we look at the resolvers again, when we write those resolvers, again, we know what's coming in and we know what needs to come out. So let's say if we use untyped language like JavaScript, we can actually use tools like GraphQL code generator to basically generate, if we look this, you can see here the function, that GraphQL code generator takes the information that we have from GraphQL and generates types automatically for us. So we don't need to write those types. It will always validate and make sure that the code that we write here inside each resolver is fully typed. So the input is a user, so we get the types of the user, and the output is a string. So we know we have to return a string. Everything we do in the middle that will, that won't follow this thing, our IDE, thanks to GraphQL code generator, will tell us that we're doing something wrong. So that's okay. So GraphQL, what all I described here is kind of like, let's call it GraphQL one-on-one very quickly. Yeah, like that's the basics of GraphQL. Now, a lot of people are, going about using GraphQL right now, and they're very excited. And usually, many times we see it comes mostly from the client part, and the client gets a lot of the benefits, and they put some GraphQL middleware in between. Now, that GraphQL engine can actually run on the client if you need to, but that's for another talk. But we have some GraphQL thing in the middle. The thing is, what we sometimes forget is all the backend part. So when we put this GraphQL engine in the middle, we still call the backends the same way that we used to call them before, just from the resolvers. So it saves us a lot of code. It helps us, but when I said this whole thing, when we were looking at the resolvers and I said everything is typed, that's not necessarily true, because when we're going to call a remote endpoint, let's say like a REST endpoint, we still don't know what we're going to get there. And we still don't have the typings there. So we still have any types, and it's not completely safe. So in many of the companies we worked with, that was the main thing that we saw. Like, we're coming in and we're putting in GraphQL in, and usually it's very fast success for the products. Like, the products can start working really fast. It's very easy, but then very quickly the backend APIs becomes the bottleneck. And again, GraphQL, just by having that power for the front-end teams or the API teams, it gives you, it helps with that bottleneck a lot, but we thought maybe we can do more. Like, maybe when we look at the backend APIs themselves, the HTTP calls, the gRPC calls, even the SQL calls, can we get some of the power of GraphQL also there when we call the old servers? So, we're not the first one who thought about it, and there's many ways to go about once you get GraphQL into your organization and you get to put it as a gateway or something like that. How do you, keep making more improvements into your stack on the backend? And there's many approaches that are happening in the community today. Like, this is a kind of an open area. So a lot of people, they put in front of each, they go about like saying, okay, we need to use GraphQL everywhere. Let's just put like small gateways in front of all of our different services and expose GraphQL, because GraphQL is so great. Or maybe even better, let's just take the existing services and convert them into GraphQL. Now, that sounds nice, and if we are in a small startups, maybe it makes sense. But when you're in a bit of a larger product and you're building with different teams, it might not be realistic. Like, you can't just go about all the backend teams that they have enough work on their hands, and maybe they're using like very old technologies and things like that, and go tell them, look, there's this new shiny protocol. You need to migrate right now because it's really cool. It's not going to happen. And that's one problem with it. The other problem with it is that, like, all the automatic stuff that I showed you that GraphQL does, it does that automatically for you, but it's still an execution. Like, it's still running it somewhere. And there's a big question, like, if I have a network between a client and a server, many times I want that execution to be run on the gateway or on the server because it saves network requests. But if I'm calling between service and service, maybe I care a bit less about how much network calls are being called, because they're much faster anyway, and maybe that's not my biggest problem. So, but people are still drawn into GraphQL even on the backend, and so we ask ourselves why. Like, and can we get the good parts of GraphQL where it fits and use the existing protocol where it fits? And what we thought is that, the most powerful thing that people really care about GraphQL is the consumer experience, is the fact that I can send a query and get exactly what I want. And it kind of like abstracts away a lot of the annoying stuff and the orchestration that I don't need to do. And it does it usually better than manual code. Now, the thing is, we used to do something similar before. So, we have, let's say on the backend here, we have it's one of the backends is our Swagger and one of them are gRPC. Like, they have schemas, right? So, and maybe they're not up to date, which, I can talk about it as well, but there's other technologies out there that do have a schema and do have some of the characteristics and the benefits of GraphQL. So what we thought is, like, can we use those informations and can we use those schemas and to do something interesting? And we've done something similar before. So a couple of years ago, we wrote a library called SOFA, the best way to rest. And the idea of that library is that if I have a GraphQL API, and GraphQL is kind of like, maybe in my opinion, is kind of like a superset of REST, then I should be able to take a GraphQL API and just generate automatically a REST API. And that's what we've done. So we took existing GraphQL code that we had, and then we just generated a fully typed Swagger and Open API that is just completely generated and completely automated. And the reason we did it, by the way, is just because, let's say in the organization, we introduced GraphQL and some of the teams got really excited about it, but some of the teams look at it and said, no, GraphQL is just a hype, we don't want to use it. Or they couldn't migrate to that at that point, or whatever reason. But we didn't want to maintain, a REST API and a GraphQL API, and we understood the benefits of GraphQL API. So what we've done is that now we just generated REST API, we sent it over to them, and they had no idea that they're using GraphQL. They just used REST, and they were happy, and we were happy as well because we didn't need to maintain REST. So we did that before, but this time we thought maybe we can do the other way around. Maybe on the backend side, we can take the original schemas like gRPC, Swagger, and other schemas, and maybe we can generate from those schemas GraphQL. And maybe after that, we can even merge those different schemas into one GraphQL schema. So we tried, and we did. So that's GraphQL Mesh. The idea was to take the best out of GraphQL, but using your existing services, and basically use the original protocol that you had, like whatever protocol it was, but get the best dev experience, like the powerful query experience that you get with GraphQL. And maybe you would want to use it because you have a lot of existing services and they can't migrate, or maybe you want to use it because this protocol is actually more efficient, like gRPC. So this is GraphQL Mesh. So it's basically a tool that takes any source, and this is just 4 examples, but there's many more, and you can ask me about it in the Q&A. Can take any source, convert it into a GraphQL schema, and then merge them all together into one endpoint, into one graph of all your data of your organization. Yes. So let's see a small example. I recorded like a very short demo just to demonstrate how it looks. So Mesh, the whole idea of Mesh is that it's, first of all, it just gets a configuration. So you can, and I'll mention why is it important in a second, but what we see here is, we just defined here, this is the Mesh configuration. We define 2 sources here. One is cities API, and one is a weather API. Those 2 APIs are public API written in Swagger or Open API. They're completely public, and I, as the user, have no control over them whatsoever. So I'm just defining them here. So we have a city API. I tell it where to take the Swagger source, and I also tell it which handler to use. So in that case, we're using TypeScript Swagger in order to convert Swagger into TypeScript and GraphQL. But this handler can be gRPC, OData, and any source you can think of, Thrift, and even queue systems like Kafka and things like that. So in this case, we have 2 Swagger endpoints. Now, just by defining those 2 Swagger endpoints, that's the only thing that I've done at this point. I can already start querying those endpoints for data. You can see here that I'm using, GraphiQL, which is like the cool IDE that you get with GraphQL. And I can already query for find cities using get. Now, just by the name, you can think that find cities using get is actually a REST endpoint. But here, it just looks like a GraphQL query, and I'm asking for, give me the city of Tel Aviv, and give me the city, give me the country and the name and the region. That's it. And what you saw here is that that's actually what I got. I got exactly what I want, as if it was a GraphQL endpoint, but it's not. And I didn't write any code. I just started querying it as if it was REST. Now, we have two different sources here. We have the cities and the weather, but we want to connect them together into one graph. So we want to get the weather in a city as if it was one source. Now, again, those sources I have no control of. And not only that I don't have control over, they don't know each other. So we have more customizations that we can do in Mesh. In this case, we can actually extend the schema into a new type that's called daily forecasts. And I can tell in a simple function how how to connect a city and a forecast together. And this function, by the way, as you can see here, is completely typed because we take all the schemas and we generate all the typings. So I know all the information that comes from the Places API and all the information that comes from the Weather API and their typings. And this function is fully typed. So if I get any mistake here, it will immediately tell me inside my IDE. And what that means basically, and we use here a technique called schema stitching, which maybe I'll talk about a bit later here. But what we can see here now is that now I queried not only Tel Aviv, but also the weather tomorrow in Tel Aviv. And as the querier, as the consumer, for me, it feels like someone built it specially for me. But again, those are two completely separate APIs, and they're not GraphQL at all. So what we've done here is we created schema stitching, and you can also use Apollo Federation, which I'll talk a bit about as well, on any source. It doesn't need to be GraphQL at all. So that's GraphQL Mesh, and that's just a small example of how it behaves. So GraphQL Mesh, like we have many handlers, like I demonstrated now OpenAPI and Swagger, but like I said, we have gRPC, SOAP. Of course, we can actually integrate GraphQL and also Apollo Federation, which it's very interesting. And I'll talk, if you want to ask me about that in the questions, I will be very happy to answer. Like it's actually a subject that I would love to talk about. And even SQL, like any scheme, SQL, we have even Neo4j handler and OData. By the way, an interesting story, we released the OData handler and we thought, well, what's the best or most famous or biggest OData API out there? And that's the Microsoft Graph API, which is a huge API for all the Microsoft products, and it's written in OData. So what we've done is we just converted in one go, we converted that whole API into GraphQL. Now, the interesting story is that a couple of years ago, they tried to do it manually and write a GraphQL API and failed. They failed to do it manually, and it wasn't performant enough. And with our converter, it took us 5 minutes and it works perfectly. So we started talking with them recently to see if they can integrate it into the docs and everything. Our website, by the way, has live examples in the website. You can just go to the GraphQLMesh.com, just choose one of those examples and run it in the browser. So you can run the whole Microsoft Graph API in the browser using GraphQL. So just by trying to completely type the resolvers, we thought we were doing something small, and just to get a fully typed code, what we ended up with is something much more powerful. So GraphQL Mesh we made it to be very pluggable. So these merging strategies that you just saw, like how we merged two APIs, you can use schema stitching, but you can also use federation. Now, first of all, about schema stitching, like I said, we took over schema stitching from Apollo and released a new version that is much more performant. So even if you tried schema stitching in the past and so for some reason it didn't work for you, or you heard it was deprecated, it's not. So I would encourage you to try it again. But even if schema stitching for whatever reason has a different philosophy than federation, and you prefer the federation philosophy, you can take the same query planner and federation logic that Apollo is using and using it in your own sources. And the thing is, you don't even need to have your APIs. They don't even have to be GraphQL Federation API. They can be regular GraphQL, and they don't even need to be GraphQL. They can be Open API. So you can now start using Apollo Federation with Open API or gRPC. And we have a lot of transforms, because if you build a gateway and you want to merge a lot of different APIs, you need to do a lot of transformations and maybe run to rename or extend or things like that. So this whole architecture is completely pluggable. And that's why it gives you also a lot of tools of caching each of those handlers and mocking and snapshotting in each of those handlers. And you can ask me more about it in the Q&A. And the community itself also started building really cool stuff with it. Like this guy, for example, from Under Armour, they use Hasura, which is a very powerful tool by itself. But he wanted to integrate a lot of different APIs he had with Hasura. So we just used GraphQL Mesh and merged all those different APIs together. And another really cool thing that if you think about it is that now you can use, so we have this tool that I mentioned before that's called GraphQL Inspector, which makes sure when you go into production, it's automatically makes sure that you're not making breaking changes, you're not going to have fail attempts, and when you release a new version, it's a very powerful tool. And it can be used with GraphQL. It was built in order to use GraphQL, but now that we can convert all those schemas and have all this information, we can now use GraphQL Inspector on any API, like even on Open API or gRPC or things like that, to make sure and get the same experience and the same stability over other APIs. Now, GraphQL Mesh is an SDK, so we can use it as a gateway, like as a central point that actually runs itself. But it can also be completely distributed. So each service can generate their own small SDKs, and it feels for them like they're querying a central place that has all the information and all the data graph, but without the need of actually having like a central point of failure. Like this mesh experience can be just generated as a small SDK that runs on all your services. And that's how we use it. And by the way, someone from the community created like a kind of like a library called like a GraphQL Mesh Docker or GraphQL Mesh Kubernetes. And the cool thing there is that you can actually configure a gateway, a mesh gateway, just by sending the config. You don't even need to write code, and you got the magical gateway just like that. And we didn't do it. Someone from the community did it, which was really, really interesting. So I'm gonna finish soon. I just want to mention another very, very cool idea here that I think is maybe the next step for Mesh. So like I showed you, we have a weather API that, we just generated GraphQL API and a GraphQL data from it. They didn't know nothing. Now, think about it, that you can do the same for your bank API. Usually banks are not moving fast enough to have GraphQL still. Some of them do, but not all of them. But we can now generate GraphQL API from their existing APIs. Now, more than that, we can now share it publicly. So if you created you generated a GraphQL SDK for your bank, now you can share it with the world. And now everyone who wants to consume the bank's API can use GraphQL. And the amazing thing that we saw is actually people did that for a couple of different companies, and then the companies said, "Oh, we also want to use it." So this is an extremely powerful idea that we can start creating mesh modules. We can start creating modules of mesh and slowly connect them together. So those modules can be specifically for a bank or specifically for weather, but someone can just create, take the bank module and take the weather module, connect them, and have, like, let's say, a daily forecast in all the branches of the bank, publish it, and now everyone has a data graph that connects the weather and the bank. And the weather didn't need to know about it, and the bank didn't need to know about it. And if we take it a step further, that's actually something that might become, if it's completely open source and can run anywhere and it's completely distributed, this can actually become something like the semantic web or Web 3.0, meaning suddenly we can have this registry of all kinds of data in all over the world that we can just introspect, query, and build automatic applications on. And we already see people in our mesh community starting to, put a Stripe API in, and Stripe doesn't have GraphQL, but no, they have. And Stack Exchange, and like I said, the Microsoft Graph, we see more and more people building GraphQL APIs, connect them together, and now we have like a distributed data graph all over the world. So we'll turn to questions now. If you want to, read more and like do all those things, then first of all, GraphQLMesh.com is a very good resource. Second of all, you should join our community. Like in the guild, we have a Discord channel and we have a new website. It's theguild.dev. Or you can follow me and get from there on Twitter, on GitHub, on LinkedIn. And we also, everyone who wants to just start doing GraphQL by themselves, we offer kind of like a mentorship program, because we think doing open source and doing more open source is important. So if that's interesting for you as well, just feel free to talk to us. So I think now we'll turn into questions, and I'll stop sharing my screen. Thank you.
Hi, Uri. Thank you very much for your presentation. People were really engaged, and our viewers kept coming in throughout your talk. So really interesting topic for the whole developers community that we have. I'm going to go ahead and share my screen so you can see the questions as well.
Okay, thanks.
Perfect. We do have a couple of questions that came in. So I also going to encourage everybody who hasn't submitted their questions, please do so. It takes some time until you type your questions. So yeah, make sure you submit them as fast as possible. Thanks for all the GraphQL work of yourself and the guild. This is more as a comment.
Thank you. Thank you very much. It's really appreciated.
Then what would be your preferred approach to include custom metadata in the introspection query? Example, extended a type with custom metadata.
Let me read it first. So what will be the preferred approach to include custom metadata in the introspection query? So it's a good question. First of all, so maybe directives. It depends on the use case. There's two things here. One, if you want to describe it in the schema, so that's probably directives. The other things, if you build toolings, you can actually you don't need directives. You can actually use new GraphQL. I think it's in version GraphQL.js has it in version 15, and I'm sure a lot of other implementation has it. You actually have a metadata field, and then you can add a lot of interesting things there, and we use it a lot. So we use it, for example, so if you, let's say, work in large teams, then when you use GraphQL modules and GraphQL Inspector, we can build like a visualization of which, let's say, which type belongs to each team. So that thing, you don't need to annotate it. We add this metadata using GraphQL.js according to, let's say, what module are you using, or your file structure and all those things. So There's actually, I don't know if I'm answering your question or not, and what is your use case, but I imagine one use case is if you just want to add, physical, like just write extra metadata, and that's like directives. And the other thing is just if you build toolings, automatic toolings like we do, actually with the GraphQL 15 had, really cool information that you can put on it. And yeah, I'm really recommending this approach.
Good. I hope whereas this, it was answered.
If not, you can ask again and give also the use case.
Also, you are active on Twitter, as far as I know. So
yeah, sure.
They can, I'm sure you'll be always open if they ping you there as well.
Yeah.
Our next question, and here is also the moment to remind everybody that you can upvote the question. So if you see an interesting question, make sure you also give it a like so we know that this is what interesting to you the most. Tom is asking, I have been working with the REST for quite a while. How and when would you recommend GraphQL? And when is it worth switching?
It's a good question. I think, so first of all, in most cases, you should start thinking about GraphQL from the consumer perspective, meaning in most cases, it will start from the client, because or it can be from, let's say, a machine learning service that needs to call a lot of different services as well. All those consumer perspectives, what they do usually is they call a lot of different sources. They wait for all those sources to come in, and then they need to write a bunch of code to iterate over all of that and put this data structure into something that they actually want, and then use it, whether to render to a page or whether to run some execution or data pipeline or whatever. Those are the places that, if you saw my first slides, all that work can be done automatically for you with GraphQL just by describing the schema of the data that you want and the query that you need. And all that automatic work will start for you. So, the most common use case is on the client. And I have a whole talk basically explaining why you can start and probably should start using GraphQL just on the client while still sending the actual REST calls between the client and the servers. Because let's say, you can't now approve another gateway into your organization. The architects thinks like GraphQL is just a hype, whatever reason, you can start actually using GraphQL on the client. And I have a whole talk about it, so you can, you can look for it online. I think that's the idea. Like from the consumer perspective, think from the consumer perspective first, and again, think again that the execution can be anywhere. So you can even start on the client, even though you don't have now any power over the backend. So it's like introducing Redux. You can just introduce GraphQL as an NPM package, and you don't need too many approvals for it.
Thank you. Also, we can share later on in our Slack channel the talk that Uri is talking about. So make sure you find it and have it there. Mike, another very active attendee of the week, a public research engine based on GraphQL. Is that already existing?
Public search engine? No, and I think it's a really good idea. You saw what I said about the mesh modules. I think we can build something here that is, I think that's the direction you're going to. Like, we can build something like the semantic web. We can build data sources that just expose the data, and we can choose how to render that, and we can choose how to aggregate that. Like, we can come to a place where we can have general information websites, not like, let's say news websites that decides what story needs to be up and what story needs to be down. Just the data is exposed, and we can just take the data, and the same goes for like search engines. It's a really good idea. And if you want to work on it, then ping me. I would love to work on it with you.
Perfect. So Mike, you may have a project to do next. You maybe have a busy summer ahead. Another question, how do you handle changes of the REST APIs?
It's a great question. And that was kind of like the original need. Like we had GraphQL APIs and we controlled the schema, and like with GraphQL Inspector, we made sure we're not going to break it. But the underlying service changed something, then you have to do a choice. So what we have today is that this. So let's say we have a underlying REST service. That REST service has a Swagger definition. We generated a GraphQL from it, and we listen to the responses. We look at the logs, and we make sure that what we are expected to get is actually what we're getting. But then they made a change, and let's say they didn't update the Swagger API, which usually happen. Now, because we know the expected schema, or maybe even they don't have a schema, but we still, from our side, we describe the schema that we expect from them. When we look at the logs, and we can do it in in an intrusive way or not intrusive way, we can suddenly understand that there's a problem here. So first of all, we get to understand it immediately. Like we get to understand it before, maybe even in the let's say in the integration environment, or in like a dev environment before we're going into production. But it's the same goes into production. And now we have two choices. First of all, we can go to the REST teams and go yell at them. And the other, which happens a lot, and the other option is that we have to update, and we have to update our public API, and we have to change it. And if it's breaking, it has to be breaking. But but two things here. First, we know earlier that it happens. We know exactly also what happened, like what broke. And the other thing, when we choose to break something, thanks to Inspector, we know all the consumers. So we know exactly what's going to be breaking, which also helps. Like even if many times you have to break, you have no options because the REST teams are still, are not connected to us and whatever. We know how to handle and mitigate that problem. So yeah, it's a good question. Very good question.
Thank you for the detailed answer. How is this different from federation?
Another good question. So it's not different. So the merging strategies that you saw, like how do we merge different APIs? We can also use federation. We can also use federation on how to merge those things. The main difference, I think, is with federation, Apollo wants you to buy into that gateway. So you need to come with an Apollo gateway. You need that the underlying services would be not just GraphQL, but also federated GraphQL services, which is like an extension of GraphQL that currently only Apollo is using. It's a very good idea, but it's a big buy-in. So you need to kind of like now do all the work and change your services to be federated, and maybe change them to be GraphQL. That's a lot of work, and it might not necessarily solve the things that you actually need. And that's why one of the reasons we created GraphQL Mesh. So we wanted you to solve each issue when you need it to. So if you have a lot of different, let's say, existing services with REST or gRPC or something like that, first, and you want the GraphQL API, first, just, you can just use Mesh, and you can use stitching or federation to merge them together, but you didn't need to change them at all. And you didn't need to do manual work. So you can gradually adopt federation until you can start with Mesh and gradually get to federation if you actually see the need. But I mean, I think that in many cases, you really don't have to. And what we saw is that once we give people the option to gradually adopt it and solve their issues, there's less people, let's say, that go all the way in and the full bind of the Apollo gateway. It's still an amazing technology, and it solves a lot of issues. But what I would just say is that ask yourself why you want to use Apollo Federation and break it down into small steps, and then see if you can solve them gradually.
So now I know how to do it, or how Uri would do it.
Yeah, we do it like, I mean, and there's a bigger question here, which federation or stitching or whatever, there's a big question of, these two technologies anyway are basically saying that you have a remote execution of GraphQL. You have GraphQL at the front and another GraphQL at the back. And I'm not sure that in most cases, you don't really need that. Like you can just, Facebook is not using federation and is not using stitching. It just takes the source code and generates all those different schemas that are modularized, for example, with GraphQL modules, and builds this unified gateway at build time, which is much simpler, it's more performant, and it's safer. So ask yourself, before you're doing everything distributed, why are you actually doing it?
Yeah. Thank you, Uri. Ignacio, also another very active viewer of ours. I work on a project that consumes tons of data, distributed on many tables, SQL, and it's really complex in terms of joining data. Could Mesh simplify it?
I think so, yes. I think, I mean, it's Mesh or maybe also other technologies. There's a lot of technologies out there that takes SQL and converts it automatically to GraphQL. Both SQL and GraphQL are very powerful, and both have different strengths. It's I would say it depends on the use case. So you can, if you have many different tables and many, like, it depends on how you want to consume the data. We did see a lot of times where, especially like in data pipelines, services and things like that, that they don't need the whole complex SQL queries. They could just describe it in GraphQL in a much simplified way, and it's good enough for them, and it saves them a lot of work. So yeah, I think it depends on the use case, but I think we saw many times that on a service-to-service communication, when you want to consume a lot of data from different services, it definitely helps, and that's the power of Mesh, that it doesn't need to be a central point that you query. It can be on the consumer part, sits there and send all the distributed calls. So you can start having this nice experience without now having like a central point that is point of failure. I would add that like very cool scenario that we see is that in a lot of architecture, you have event-based, like event bus, and a lot of services listening to the event bus. And a very common scenario is that as a service, I'm listening to some event, let's say from Kafka. And then I want to, once like the event comes, I need to query a number of different sources. Once I get the sources, I do some manipulations, and then I start getting, then I'm starting my actual work. With GraphQL Mesh, we can abstract all of that with basically GraphQL subscriptions. So I can just subscribe to an event, and with GraphQL subscriptions, you subscribe to an event and you query data that would come with that event. So to enrich that data. So we can just have the machine learning service, let's say, or the data pipeline service, subscribe to an event, query what it needs, doesn't care where it comes from, and then just start working. So it simplifies a lot of that code in that architecture.
But at the end, it depends on your case.
Yeah.
On your project. So maybe Ignacio, you can also, like, I'm giving a lot of work to Uri for the summer here. You can also think Uri, maybe if he can advise you a bit more concretely, you share the project.
Yeah, everyone here, like, feel free to like just contact me. Like, I love those questions, and I love to sit with people and get more use cases, like, for sure.
Good to know. So I'll keep sending people to you. The next question is more logistical. Would we share the slides on Slack? From our side, yes. If Uri is with
it's a good question. So it's everyone asks me because of the nice animations and everything. So the thing is, someone actually really laughed at me about it. I open source everything I do except the slides. So so if you can forgive me that we're open sourcing so many libraries and so much work, the animations I don't know, maybe it's an artistic thing, but I don't open source this and I just use it for my slides. But yeah, so but it will be online on videos and stuff. So
exactly, that's what I want to say. So the sessions are recorded, so you can always go back in the video and see the slides. So I also completely understand this because you have also put I'm sure a big effort into those slides, and as you said, like you share so much more that the slides are.
It's weird. I had the founder of Hazura like always laughs at me about that, because like I open source like how I manage my my financial applications, and I open source all the libraries, and everything I do is open source. But then the slides I don't open source. So yeah, I hope you'll forgive me.
Yeah, you don't have to, so it's okay. Good. We do have some more minutes to take a couple of more questions. Can you describe the efforts involved in implementing Mesh for one non-GraphQL API?
A good question. So, I mean, all you need to do is get a schema. So, and that's the point of Mesh, if I understand the question correctly. So, let's say you just have, I don't know, three different REST APIs. And now you just want to get GraphQL API, you don't want to think about it, you don't know GraphQL. Then actually there's this project that I referenced, and you can Google GraphQL Mesh Docker. So you can just define in the YAML file, the mesh config. There you just need to point to the source of the schemas of those REST endpoints. It can be Swagger, and it can be whatever is comfortable for you. If it's gRPC, or ORData, depends on those slides. If those sources, if they don't have sources, you can just create them. So you can just create a new Swagger definitions of what you think is supposed to come, and then you just define the handler, and that's it. And you can, with this GraphQL Mesh Docker, you put it as an input, and you get a Docker container that you can just run, and it will work. So, and again, this is the community did, and it's amazing work. So this is the first step. Yeah, like there's a lot. Once you do that, you would see that you would want more and more, and you would want to change the schema, and you want different types. But as a first step, it's a very powerful step and easy, relatively.
Thank you for also answering this so detailed. We do have time for one more question or two. Let's see, depends on the answers. Aren't you shifting the load from the client to the server with GraphQL?
Good question. Depends on where that execution runs. So, like I showed, is that this automatic execution of GraphQL that I showed in the slides, in most cases, it runs on the server and not on the client. So that means that the client now basically becomes slimmer, like the other way around, like the load, like exactly what you said, like the load is taking down from the client into the server, which is, it's a good thing in many cases and that's why Facebook did that. Like, first of all, it saves a lot of code, and so the bundle size is smaller. But also, the main difference is the network. So there's much less, if you are on a mobile network or stuff like that, there's much less information coming through the network. But it's true that execution, even if automatic, it runs on the server. What we've done is that we said, why? Maybe it doesn't have to be. Maybe we can take that execution. It will do the same thing, but the execution can be run anywhere. So the first place that we did it was just on the client. So we take the GraphQL server, we just run the GraphQL server. This is why I call it the GraphQL engine and not the GraphQL server. We run the GraphQL engine on the client. And there's many companies that starts like that. You don't shift any load on the server, and you get a lot of the benefits already. And then you can start picking and choosing where do you want the execution to be. And in GraphQL Mesh, it's the same idea, that execution can be run on the provider, like the classical GraphQL, but then it can also run on the consumer. So now that machine learning service can run all that automatic execution without loading more stuff on the backends or on the providers? It's a really good question. So yeah, I think the main, if you just start GraphQL, that's what people display because that's how Facebook using it. But I think you can move to the execution wherever you want to run that execution for whatever reason.
Good. Thank you very much for this answer as well. We are actually kind of running out of time already. So the next questions, we will send them to you after the week. So maybe you can answer them in a blog post or on Twitter. But we will need to go to a coffee break right now. So yeah, if you want, maybe you can choose one last questions that you like and you feel like you want to answer.
Oh, yeah.
I'm going to scroll slowly through them if you want.
Yeah. Okay, and there's a lot of good questions. I mean, ask everything because I really want to answer it all. There was one on the top that said, like, you know, how can I guarantee? And there was one at the bottom that mentioned SOAP. And both of those are, oh, and there's, oh, the deltas also, that's very interesting. So about the delta, I will just say, there's an online talk that I gave about GraphQL subscriptions in ReactiveConf. So you should check it out. I talk a lot about this area. About, you know, what you said about, is the market more open-minded about SOAP? Yes. By the way, GraphQL Mesh supports SOAP and WSDLs. And the question, and what you can see there is that we take the good stuff from SOAPs and WSDLs, like the schemas and the tightly typed services, but then we get the query language from GraphQL. So it's very interesting actually to use GraphQL Mesh on top of SOAP APIs. And the guarantee stuff, GraphQL itself guarantees the consistency, but with GraphQL Mesh, because we can actually use the underlying technologies that might not guarantee it, like Swagger doesn't guarantee nothing, we have like extensions that actually look at your logs or look at the response and can do whatever you want. So we can compare those into the actual schema, and we can do, or just alert you, or if you really want to do it, we can actually block it or send an error or something like that. So yeah.
Cool. There's some comments as I also feel about the whole presentation. Awesome presentation, Uri. Thanks.
Thank you.
So we will make sure you get all these questions that are left over that we couldn't answer right now. But this is very nice. I want to thank the attendees, the viewers being so active and asking questions, as well you for taking the time and answering them so in detail. That's always very appreciated from our audience.
And thank you for having me, and thank you everyone for listening. And also, like, feel free to just contact me directly. Like my Twitter or even my email is public on the GitHub. Just ask me whatever you want.
That's how we got him.
Yeah.
And he replies, as you can see. So cool. Yeah, thank you very much for your time, for participating. For everybody else, we are gonna go into a short coffee break, and we'll be back exactly at 3 p.m. Meanwhile, you can also give us feedback about Uri's talk in the poll that we're going to be displaying anytime on Slido. So you can just vote, tell us what you liked or what you want to see more. And yeah, at 3 p.m. we'll be back with Alex Waldherr and her talk about quantum computing. And I just want to mention that she's 18 years old. So already deep into the topic, I'm sure you can learn a lot from her. So have your coffee, and we'll be back in 25 minutes. Hi everybody, we keep asking each other here in the office if we are ready to go live, and we are, and I hope you are also ready for our next talk, because it's from an 18-year-old Alexandra Waldherr. But before we go to this, actually it will not be a proper intro if I don't remind you to use Slido and to ask questions, submit your comments, and just interact with the speaker as much as possible. It's very important and it really helps everybody who is giving the talk. I just want to also mention that actually with this break and with the next talk, we're halfway through the agenda today. So it is getting a bit sad here, knowing that we're going to have only 3 more talks for the WeAreDevelopers Live Week. And I want to remind you that we're going to have a small closing ceremony after the last talk, so make sure you stay tuned and celebrate the achievements of this week with us at the end. And before we go to Alex's talk, I want to thank our community partner, Tech to Impact, and let you know that they have a mentorship program open, applications open for the mentorship program. So you can go on their website, Tech to Impact, and see how you can help and join a global network of startups who are doing tech for good. If you're interested, they need all kinds of profiles, from marketing to sales to developers. So if you're interested in the topic, you can go ahead and check if you can help some startups grow in that industry. So without further ado, I actually want to present you Alex Waldherr, our favorite speakers of WeAreDevelopers. She's a student in chemical engineering. And since she's been 12 years old, she's passionate about science and particularly physics, programming, and chemistry. In 2019, she helped with a research project in CERN, and the other achievement of the year was that she spoke at the WeAreDevelopers Vienna Congress for the first time. She was supposed to speak also in our Berlin event this year, but we moved this online. So let's give a big round of applause, virtual applause, for Alex Waldherr. Hi Alex, very happy to be you here. As I already introduced to the audience, you've been a favorite speaker of ours, and last year the stage was crowded. People wanted to come in even though we reached the capacity. So I'm sure now people are also looking forward for your talk, because we have no limit here in the virtual on the virtual stage. I see that you already shared your screen, so the stage is yours. And
thank you.
Remind everybody that we'll be taking the questions at the end.
Yeah. Thank you.
Go ahead.
Okay, so hello everybody. I'm very glad to be here, and I hope I meet the standards from December. I have been quite occupied the last few weeks with final exams, but so nothing math heavy today. We will go into a little bit of a story. So as already was mentioned, I worked at CERN, and the really cool thing that you will find as soon as you walk in is that every street is named after a famous physicist. And this is really cool. So you will find Feynman there or Rutherford, but my favorite one was actually F. Bloch, after I found out what he stands for, really. So Felix Bloch was the first general director of CERN. And the really cool thing is that he actually has also a close connection to quantum computing. So we start here at the timeline in 1952, and Felix Bloch got his Nobel Prize for NMR in 1952. And NMR is just nuclear magnetic resonance, and it's a technique that also chemists use quite a lot to find out how specific atoms are aligned and how they interact with a magnetic field. And you can therefore use the spin of nuclei from some specific elements. But this was not a quantum computer yet, but quite a quantum leap towards quantum computers. because then in 1960 and in 1982, Richard Feynman said really famous words and gave talks about miniature stuff, like building really small robots. And one of his most favorite or most often quoted talks is "There's plenty of room at the bottom." But what I find even more interesting is in 1982, he said he wanted to simulate physics with computers. And this was actually the kind of first proposal of a quantum computer. And in 1985 and 1988, David Deutsch made this proposal much more concrete and proved that you can even do better than a normal Turing machine. And he also stated that it would be quite cool to have a gate model approach for quantum computers, which actually means that we have a qubit and we apply gate after gate to it. So a little bit like in a normal computer, but all these gates can be reversible, and all of these gates should be universal for all quantum devices that we have. So he wanted to make it more a bigger community. And after this, the foundations for quantum computing were kind of founded, and then the algorithms followed. So with Shor's algorithm and Gruber's algorithm in 1949, and Grover's algorithm in 1996. And this was just everything theoretical. But then in Vienna in 1998, the first quantum computing language was developed at a technical university, which I found actually pretty cool, because like Vienna, which is very nice. And in the same year at MIT, the first quantum computer was developed, and it was developed by Gershenfeld and Kuan. And the really cool thing is that they used the NMR technique that Bloch had proposed almost 40 years before. So the first quantum computer was really done with NMR. And then in 2001, IBM also chimed with an NMR quantum computer, and they showed that Shor's algorithm was possible on it. And then in 2019, everybody has already switched to superconducting circuits, which we'll cover a little bit later. And Google claimed quantum supremacy in some subjects, which mean we are better with quantum computers solving a certain problem than we can do at the moment with normal computers, with classical ones. And this is actually one of the two things that classical computing is not good at. So when we have a qubit, we do not have zeros and ones anymore, but we have superposition and entanglement and all these fancy words that everybody heard of, but nobody really can 100% grasp, because quantum mechanics is something that is not intuitive for anybody of us. Also if I do maths, yes, we can trust the numbers, but you cannot really trust our intuition in these topics. But what a qubit can do for us is it can increase the complexity and the speed of our today's computations, or it can help us to do real-world exploration of quantum systems. For example, in chemistry, quantum computers are the only way to solve specific equations that we need to understand the chemical quantum systems. So everybody just thinks of, okay, we want to make it better and faster and polynomial time, and we think also about what can be better explained with quantum computing. So this is what I'm going to show a little bit today, how we can and why we should better compute the future. And we will start with how we can, or how we actually are doing it at the moment. And we will start with the layout of a quantum computer. So there are different layers. And the first one is the logical layer. So this is where our code sits, and it's still quite mathematical. And it works a lot with matrices and matrix multiplications. And then we need, of course, something that provides a much more machine code similar layer, and this is our virtual layer. And in between there is some error correction and communication. And the virtual layer is often managed in a cloud, because it's quite hard for you at home to have a quantum computer. So you most of the time connect to something in America or in England, for example. And this virtual layer is critically important. It's like the compiler, but it doesn't really do machine code. Much more, it ends and results in specific physical operations on physical qubits, and it's more like an experimental layer. So don't imagine like the qubits being like a computer, but it's more like an experiment that sits in a lab or in a specific environment, and it's very fragile, and you have to put in lasers and everything else, and exactly the right time with exactly the right length to put in exactly the right energy and to switch between different states. So logical layer, virtual layer, and physical layer are the most important ones. And we will start with the most fragile one, with the physical layer, so the hardware. And if we look at NMR, just briefly, I won't cover it in detail, but so you know what's behind a quantum computer. We have often some kind of phosphorus, like kind of structure, and then we can put in, for example, one silicon atom. We have silicon, and we put in one phosphorus atom, sorry. And the cool thing is that silicon does not interact with a magnetic field, NMR, but phosphorus does in our case. And so if we align a magnetic gradient along this qubit, we can see that it can have two positions, so up or down. And we can align those two measurements, 0 or 1. And we can only measure 0 or 1. And we can also only switch between low and high energy with one specific frequency, say 200 megahertz or something like that. So it's like you cannot go in between. That's not possible in quantum mechanics, because you can think of it like in a house. You have the first floor and then the second floor. And if you go into an elevator, you cannot go out in between. It's like either first or second floor. There's nothing in between. So if you don't put in the right amount of energy, it still does something to the system. So actually your qubit should end up somewhere here. But in quantum computing, as it is not possible that this qubit ends up here, it kind of splits the probability of where it could be afterwards. And it splits the energy proportional to where it can be afterwards. So if you put in 20% more energy, for example, it can be for 20% in the upper case, and for 80%, it has not had any impact, so it will be in the lower case. And as you only had one qubit, this does not really impact it, and it is called superposition. So you split it up between different outcomes, and you don't really know what it is until you measure it. And in between the measurements, you can do a lot with these superpositions. And you can also do superpositions of this state again, and so on. And this is what gives quantum computing the huge power of parallelism. But NMR is not the thing that's used nowadays most often, but actually it's our superconducting circuits. And those are the things we also see in the chips from IBM or from Google. And those are the things that are cooled down to really like near absolute zero, like some microkelvin, I think, millikelvin above absolute zero. And this is because we have some oscillating circuits, and the frequency of the oscillating circuits is immensely influenced if there's some temperature change. Also, of course, the superconduction is extremely changed if there's a temperature change. And you can make these superconducting circuits, and one of those superconducting circuits then has different frequencies. And between those different frequencies, there is again an energy barrier. So you can only have one or the other one. And you can jump between those during your calculations. And you can put it in superposition between those frequencies also in your calculations. And the thing how you can connect different of these superconducting circuits to make them entangled and to make them actually interact and communicate with each other is, for example, through Josephson junctions. And yeah, so this was a little bit of the hardware. There's also again ion traps, and there are also other models. For example, nuclear magnetic resonance may be influenced by nuclear electric magnetic inference. And yeah, this is really cool. But let's go to the virtual area. So as we do not really have to focus on the hardware, as we won't build a quantum computer probably at home, the virtual area is much more important for us. And if we look at which companies at the moment are really into quantum development, there's IBM, Google, Microsoft, and D-Wave. And all of those use superconducting circuits, which definitely shows that companies are in favor of superconducting circuits. And three of the big companies like IBM, Google, and Microsoft all strive to achieve a universal quantum computer, which means that they want to have a quantum computer that can solve any problem that a quantum computer could potentially solve, because they're subclasses of quantum computers, and they want to have all those subclasses combined into one quantum computer. And the most often used approach is the gate model approach, so that you can just really individualize every circuit. And IBM for this has its platform named Q-Experience, and the framework which you can use or which you can implement is Qiskit, often quite similar to Python. And then Google, on the other hand, says, okay, we are not as experienced as IBM, because quantum computers at the moment are really noisy, and we don't really know in which direction we will grow with quantum computers. So they focus on an NISQ focus or approach, which is actually noisy intermediate scale quantum computer, because ours are still noisy, we have some errors, they're intermediate scale, we do not have large ones yet. And they open the code to everybody and say, okay, this is alpha or beta version, I think, and it's not as advanced, but you can still play around with it and also give feedback, and so everybody can kind of find out how we can better compute the future. And Microsoft also has a quite stable release already, and they worked after, I think since 2010, they really worked on it, and it's called the Quantum Development Kit, and it's called Q#, and also powered in the backend by C#. And you can simulate a lot of stuff with Microsoft stuff on your own device, for example. And for Google, you have to use the simulator at Google's, and by IBM, you can use the simulators or the real backends at IBM. And then we have D-Wave, and it's called the quantum computing company. But sometimes people really discussed where there is a quantum computing company because they use adiabatic quantum computing. And this is the easiest way to scale up quantum computing. That's why if you heard that D-Wave has about 2,000 qubits or something like that, it's not like the universal qubits, but adiabatic qubits. And it's still of quite good use. So I think it is quantum computing because it's good in, for example, AI or finding an optimization for a certain problem. And the cool thing is, if you use quantum systems, you don't have to find out where your local minima are, your global minima are, so you can avoid the local minima. Because quantum computing helps you to tunnel between over this barrier. So you just tunnel in between the barrier, and then you'll find your global minima. And this is really, really cool, because normally you have these problems. For example, if you've ever trained neural networks, sometimes they fall into this trap and like are overtrained in a certain field. And if you use this, it's much more useful for many areas. And NASA used it, and Google also bought one from D-Wave. Yeah, so one specific field, still a cool application in my sense. But we will go to IBM because I think it's like the most popular, the most advanced framework and cloud platform that you can use. And I will just briefly introduce you to how you can start and play around with it, because I think the most important thing is play around with it, find out what works, what does not work, what you do understand, what you do not understand, because otherwise I think there's just so much distance between the public and like quantum computers that we cannot communicate where we could use them. So, okay, the first thing is you go to quantumcomputingibm.com, and then you will find a sign-in form, and it's actually quite easy, everything, and also for free. And then you come to a screen where you can just drop your gate somewhere and do something random, like I did, I think here, and get some results. And if you do not want it on the in the web, you can also go to qiskit.org. There you have all the documentation for Qiskit, and you can, for example, install Qiskit as a pip install Qiskit, and then use Qiskit in any Python application. And also, besides the Slack channel, there's also a really cool Stack Overflow part for quantum computing, quite math heavy, but really nice if you want to dive deeper. And in the end, quantum computing is maybe math heavy in some parts, but it's actually quite easy to build. So every quantum program at the moment is quite well structured. And I will just briefly go through this because it's so simple that everybody can easily comprehend this. So the first thing is you start to establish a circuit. So you actually name a variable, like this is my circuit, for example, and then you define how many qubits you need and how many classical bits you need. And when you have that, you just start to apply gates and grow the circuit and put them in entanglement. And yeah, that is not the hard part. And then you send your circuit to the backend. So you package everything, and this can either be a real quantum device. For example, IBM provides real quantum devices, or it can be a simulator. And I think both are quite nice. Simulator is better if you want to have like accurate results for small circuits, and real quantum devices, yeah, we need it for bigger or more complicated applications. And then you will get back from one of those your results, and you will analyze them, because it's quite important to analyze the results. The results are not as straightforward as we would think. And from the results, you can then see, okay, this worked, or this calculation was really nice, and this data vector was interesting for me. So let's quickly jump to the logical layer, to the code, and to what our math is actually. So it's not 0 or 1. It's a little bit more math, but we can really nice visualize it on the Bloch sphere. And by coincidence, this was also invented by Felix Bloch, so he definitely has some help provided for us in quantum computing. And in the end, you can define every qubit, like the little dark spot on this sphere with the wave function. And those has two coefficients, which is alpha and beta, and those we can put into a state vector, because we do not always write the wave function, but we said, okay, it's a mathematical consensus in quantum computing. We define the state vector like this, and those can be imaginary numbers or normal numbers. And for two simple examples, if we have 1 and 0, we see, okay, alpha is 1, so we have state 0 to 100%. And here we see, okay, state as beta is 1, so state 1 is 100%. Okay, so alpha is here and beta is here. And state vector is alpha, beta. And when we measure this, we cannot directly measure the qubit if it's not on the north or south pole of the sphere. So what we do when we measure a qubit is that it collapses the wave function, and it either becomes 0 or it becomes 1 to 100%. And only by repeating this experiment a lot of times, we can then see, okay, 80% of the time it stays in the ground position, 20% of the time it goes into the upper position. And if we have a complicated calculation, in the end we can redefine where our output was. So if we square our wave function, this is the mathematical expression or the mathematical correlation between wave function and the probability which gives us the measurement, and we then get the probability of measuring the 0 state or the 1 state. And for example, if you put the qubit into a position, for example, with the header mud gate right at the equator, then you will get 0 or 1 to 50% chance. So it's actually a superposition, exactly a superposition between 0 and 1. And to move our qubit in the end around here on the whole sphere, we use the U gate, which is the universal gate. It seems quite complicated, the formula, but a lot of really cool people have found nice other ways to break the matrix down and to make it easier and to define some standard gates that we often use for specific tasks. And for example, the header mud gate is quite often used, and also the X gate, the CNOT gate, and the identity gate. And the identity gate in the end is just like an identity matrix. So for you as a programmer, you just have to think of, okay, I have this state vector and I multiply it with my gate matrix, and then I will get the new state vector. And this new state vector can do other things. And this is how you actually build and grow your circuit, right? Okay, so this is a really short example how it could look like. So in the end, we say, okay, we have a circuit, and I said, okay, 2 qubits and 2 classical bits, and then I put on some different gates like H gate, CNOT gate, U gate, blah, blah. And then we measured it, and then I said, okay, put the circuit here, draw it, and then I packaged all the stuff and sent it to the IBM Q London provider backend. And the IBM Q London is one of their quantum devices. And I said, okay, give me 500 shots, so run it 500 times, and then give me back the probability and plot it as an histogram. And this was the probability, and I'm quite satisfied with it, because it should be a little bit random. And yeah, so this is actually quite, it's not hard, like make a circuit, apply some gates, play around with it, send it to simulator or device, and plot the outcome, and then try to understand a little bit how it came to be. And yeah, this is how I learned, and maybe it helps you too. Okay, so just to recap, so we have the logical layer at the top. This is where the code sits. The matrix is quite a little bit math focused, but it's fun to play around with it. Then we have our virtual layer, where we have actually for example, the Q Experience cloud, where our code is then transformed into machine code. And this is actually what makes code and qubits work together, because atoms alone would not be a quantum computer, and our code alone, our mathematical matrices, would not be a quantum computer. And this virtual layer then accesses our experience. Okay, so this was how a quantum computer is working in like an overview. And now it's why quantum computers. And I think there are 2 really nice quotes. The first one is from Einstein, and he said it may be the same questions, but the answers have changed. So maybe in some fields we still have the same questions as years ago, but maybe quantum computers help us to find different, better answers or more accurate answers. That would be quite nice. And on the other hand, what we cannot create, we do not understand. This is also cool, and I think it was the quote from Feynman. So if we cannot build a quantum computer, we also do not understand quantum mechanics. And in some cases, quantum mechanics is really vital to our future, right? And if we look at the graphic again, so we have speed and complexity and real-world exploration, but this is so it's so abstract. And I was really satisfied when I found this really nice example of one thing that you can maybe kind of correlate with. So quantum neural networks are neural network models which are based on the principles of quantum mechanics. So that's cool. We try to combine some neural network with quantum computers. Okay. There are 2 different approaches to QNN research. One, exploiting quantum information processing to improve existing neural network models. So this is just focusing on complexity and speed. So they want to make the models that they have better with quantum computing. And the other one is searching for potential quantum effects in the brain. So this is more like, okay, we want to understand the real world better. And we do not know if it's really 100% beneficial, but it's quite nice that we can target many different fields of it. And here we can see that this stuff here is what only quantum computers can enable for us. And we still do not really 100% know what actually lies in there. Some may be lying on the boundary, but many things we do not really know. Because in quantum computing also, a lot of people come from really scientific fields and not only from business sides. So we actually need people to discuss what they maybe need and what quantum computers can give them to find out what could be possible. And here, for example, factoring is in here for short algorithm. And yeah, so this is called chemistry, materials, machine learning, optimization, really nice applications that sometimes are on the boundary of what our computers can manage. And on the other hand, the biggest argument against quantum computers is definitely first the energy efficiency, which is quite low at the moment, and then the error rates. So we are still worse with quantum computers in 2020 than vacuum tubes were in 1950. And this is, of course, it's a little bit embarrassing. And on the other hand, we still get much more dense results from quantum computers than we get from vacuum tubes. So I think it still needs our time and our thoughts on quantum computing to improve really which backends we use, which hardware we use, how fragile our systems are with the hardware we use. And IBM has this really neat quantity graphic where you see that the quantity of complexity increases definitely as soon as you add one qubit, because then the qubits interfere with each other and not only entangle, and it makes it harder. But the one cool thing that quantum computing changes in the end is that we learned to work in different fields much better together. And here, 3 websites that I really like to keep up a little bit with what's going on in quantum computing. So the first thing is from MIT, and they put a lot of quantum computing information on there. Much of the science field, what was done in the science area, what was done physically, which qubit approaches are new. And for example, they found some really cool particles, Majorana fermions on gold, which may be a step towards more stable quantum computers. Then the second one is quantum computing report, where businesses tell what they would need or how they try to get closer to quantum computing, and also what does not work for them. Also really interesting, because if we do know what does not work, we may be better in what works. And then mathematically based is quantum algorithms too. A lot of algorithms, really cool and quite math based, but it helps to understand what's going on with the really complicated and high level stuff, as well as with the low level stuff that's fun to play around with. In the end, I think quantum computing is like the main framework we nowadays have to shift our focuses from what a computer needs to be like to what we do not know yet. So if we have a computer, it can answer a lot of questions, and classical computers will still be better, for example, in storing information or copying stuff, or giving some certain answers for certain problems. But on the other hand, quantum computing opens our perspective of the world and what we know a lot. So for example, if we think that we can calculate with atoms, why can we not also produce in smaller quantities? Why can we not use smaller systems? And Feynman said in his talk also, we do not know yet where it leads to, but we definitely can be the people who make the path, right? And I think quantum computing is quite a diverse field, but it has its potential. And it needs everybody's opinion so that we can develop it in the direction that everybody wants it to be. And it also needs a lot of people to play around with it, because then we see which errors are the most often. And yeah, so what is your opinion on the quantum topic? I know this talk was a little bit short, but I had finance exam this week, and it was better short and kind of coherent than somehow messy and error prone like quantum computers. And yeah, do you have any questions? That would be interesting for me. Yeah, thank you.
Thank you, Alex. So energetic, so nice to have you again on our stage, even though virtual. I'm gonna share my screen to see what questions we have or comments. And meanwhile, I would encourage everybody who is watching us on YouTube to go ahead to slido.com, use the code LIVE2020, so you can submit your questions. Or if you are on the WeAreDevelopers website, you see the questions right next to the video on that side. So then you know what to ask Alex, or how to ask Alex. Yeah. So yeah, there is a comment from Mike about the cat.
Yeah, thank Microsoft. I also really like the icon. It's really cool, I think. Yeah. I think Schrödinger's cat is just one of the most famous examples, like throwing Schrödinger's cat. But it still shows us that we do not have an intuitive understanding of quantum mechanics. And I also believe that if we only focus on visuals, we will not always lead to better results, especially in quantum computing, because maths is here a little bit more applicable. But I love cats, and Schrödinger's cat is perfect, and Schrödinger was an Austrian physicist, so yeah, perfect. Yeah.
Thank you for commenting on this. And then we have another question. Are there already real business applications you know of outside the scientific things I'm hearing?
Yeah, I think there are some really cool applications, and there's also the framework Aqua by IBM, where they try to implement it in the financial sector as well as in, for example, chemistry or a larger scale like drug development. What I find really most interesting is that you have the problem that if quantum computers really can break security in some places, you can also prepare such fragile systems that you can be much better in transferring information extremely secure. And for example, between China and Austria, there's a satellite called Meteos. It's one of my favorite examples. And they transfer really cool and really stable and also highly secure data between China and Austria. And for example, it's still in the research phase, but they also transfer a picture of Schrödinger's cat by photons. So I think the problem with quantum computers in industries at the moment that we do not have so stable quantum computers that we can focus on large problems, but we also need the data from industries so that we can make it better. And I think especially in the telecommunication network, there's a lot of interest in quantum computers, and there were also conferences where a lot of really big companies wanted to know how they can do better secure key communication. This is a cool topic. So if you want to look into secure key communication with quantum computers, that's definitely one of the first applications I think they would target. Yeah.
Thank you, Alex. Our next question just came in. How do we integrate code bases with quantum computing?
So for example, if you connect to the backend of IBM, they also have some APIs that you can use. And on the end, as soon as you can pull the results and can do something with it, you can also store the results in any variable and then use the variable otherwise. And there was also during the Corona time a really cool talk by a really cool webinar actually at WeAreDevelopers about a quantum computing website. It was also really cool. So if you want to look at that, this was also quite nice. I think it still depends on you how you can integrate it really well, how you can implement it visually or not visually. There's also like an app where you can flip coins with quantum computers. So it depends on, yeah, I think your creativity most of the time, because it's open source, so everybody can use it as they wish. Yeah.
The website, I believe, was called Shine.
I think, yeah.
Yes, cool. Questions started coming in. Are we as classic coders even able to from the mindset to form, I guess it's typo, form the mindset to do quantum programming?
Oh yes, I think definitely, because I think I came from a chemistry field and I got used to computing, so programming. So I think if I'm coming from programming, quantum computing is not that far away. I think the mindset of quantum computing is just that you can be a little bit more creative, and it is still in a much more it's in an earlier phase. So be more open to the community, bring in ideas. And I think the most important thing in quantum computing is that you are open to physics, maths, and also other people. It's like not only one language, but it's something that's still developing and still finding where it's best. Like we are not sure if superconducting circuits are the future really. Maybe ion traps are, we don't know. So this is why everybody can somehow implement it. And also I think the cool thing is you can play around with it. So definitely the mindset isn't everybody if you are still a little bit curious. So if you ever wondered why there are black holes or what quantum mechanics is, then quantum computing is like nothing else than a little bit of an answer. And yeah,
there's a lot to explore for sure.
Yeah, definitely.
Awesome job. I surprisingly understood much of it. Thanks. That's a nice comment. Yeah.
Thank you.
Here a more personal question. Where do you see yourself in 5 years within your research?
So as I finished high school this year and also did my diploma thesis, I think I will stay a little bit in the chemical field, but still definitely target physics or like biomedicine, because those are all the fields where you have molecular science. And I think the cool thing in molecular science is that it becomes quite interdisciplinary. So quantum computers would not work without different fields and without different people. And but my most favorite topic is where you have kind of this really math-focused but tiny aspects of life that you can combine with with kind of everyday solutions. So you kind of have applications from tiny things. So you see potential in tiny things and make something big out of it. I don't know if this is really a cool research topic, and if there's even any like postdoc place open for something like that. But yeah, if we do not try, we do not know. So yeah.
Okay, that's a good mindset to have. Another question, is graph theory used in quantum computing?
Yes, it is a little bit used in quantum computing. I'm not really good in graph theory. I'm really sorry, but there's also topological quantum computing, which kind of targets the area a little bit. And there's also variational quantum eigensolver, which also uses graph theory a little bit for some kind of optimization problems. But I'm not 100% sure if this really was how you would implement graph theory, because I'm not 100% sure about the topic. It's only what I like read and heard. So feel free to destroy me afterwards. Yeah.
Okay. Thank you for your answer. What connections do you see using AI data science with quantum computing? What areas do you see a good development of quantum computing?
Okay, so I will start with the AI and data science. So as we said, there are some approaches where you can make optimization work much better with quantum computers and also much more universal. So I think this is quite cool. You can also make it much faster with quantum computers in some areas, and you can also make it much more, there's some approaches to help you understand the training of the model much better and make it much more secure. There are some cool talks from IBM. I can afterwards find out the links and send them. And the other question is, what areas do you see a good development of quantum computing? Yeah, in my field, definitely chemical engineering, because it's the one that is interesting for me the most. Because, for example, I found now some really cool examples and solutions to the Schrödinger equations, which we did not have, I think, like 3 years ago, because it's actually quite hard if you have multi-atom systems or multi-electron systems to really define a wave function and then solve for the energy levels of the wave function. This is actually really, really hard. And it's so useful in material science because, for example, for electrical conductors or for transistors, you definitely need to know where the energy barriers are and how big the energy jumps need to be so you can make better materials with certain properties. And there is actually quite a lot of development going on that I really like to see. Yeah.
Okay, thank you for a detailed answer again. Mike is asking, you said that the operations cannot not be compared, but they will change stuff we take for granted, like security. How do you see the impact on society?
The operation can, okay. I think I understand, I hope I understand the question correctly. The operations on quantum computers are much more calculation focused than what we do with normal computers at the moment, because quantum systems are so fragile that we do not have at the moment an opportunity to really store information like long time in hardware and quantum hardware. So what we do is we send something to a quantum hardware, get the result back and store it somewhere else. So if you want to have something where you store information or use it longer time, you cannot do that at the moment with a quantum computer. At the same time, you can also not really copy and paste a quantum qubit, because if you look at the system to copy it, it destroys the measurement. Through the measurement, it destroys it. So this is what will change, yeah. So these are two things that are not the same, but it's definitely still changing, because the whole problem of normal computers is that they cannot parallelize enormously and that they cannot solve some problems in polynomial time. And I think the coolest thing would be if we could solve N and P with P and P with quantum computers, but I do not see that coming in the next years. So the impact in society I definitely see is in having the bigger perspective of the picture, as I already mentioned. I think quantum computing is something that changed our minds of what a computer is a little bit, and it may be also changing our thinking about what we can do a little bit, because if we know how to manipulate atoms, then we can maybe also do other things, like I don't know, break down barriers or racism or something like that. I think we can do a lot as a society, yeah.
And the next question also goes a bit in that direction. Do you think quantum computers interface will ever be publicly available? Maybe something like an API? And if so, when do you think this could be the case?
I think there is one already from IBM, and you also can, if you have a company, they have bigger quantum systems that you can buy access to, and this you can definitely run through an API that you can also implement. I haven't done that yet for a big application, so I'm not quite sure, and I would love to learn more about the topic. So maybe if I ever do another talk, I know that I'm going to include APIs and how you can definitely use it for your application. At the moment, I do not have the perfect answer. I'm really sorry for that. Yeah.
That's fine, no worries. A comment from another fan, infectious energy for given topic.
Thank you. That's awesome. Yeah.
Yes, I told you, I keep telling the viewers, like, give us this comment because they really encourage the speaker, and it's very nice to see them.
But the community generally is really cool here, so yeah, I'm feeling welcomed.
Yes, they are very nice indeed. So one last question, or at least for now, one last question. So we do have more time from the schedule point of view. So if there are questions, make sure you submit them on Slido. How are innovations in better energy efficiencies regarding quantum computing presently being addressed?
Okay, this targets really cool things. I think at the moment we are still at the really early level, but quantum mechanics and quantum computing and energy efficiency are cool topics, especially if we talk about solar energy, because they had some experiments also run at IBM with special bacteria where they found out that the chlorophyll that these bacteria use can be kind of better, they use quantum effects to more efficiently transfer electrons and transfer energy that is coming from the sunlight. So if we kind of understand those proteins better that are in these bacteria, we may be better to use solar energy much more efficiently than we have the ability to use with our today's solar cells. And I think also the normal chlorophyll cascade with the normal photosynthesis can be much better understood if you use quantum computers, because then you can calculate the energy levels and the dependencies of the different molecules much better to each other, and the frequency with which the molecules vibrate when they are excited and anything else. Yeah. So this is probably the most important aspect. And then, of course, material science. As we make better materials, we can be more energy efficient in general. And also, if we understand, for example, lithium ions better, then we make better energy then we make better batteries and be more energy efficient, for example, with cars. Yeah.
I could imagine this question is from Eric Steinberger, as yesterday he was giving a talk during the live week.
Yeah, that would be nice. I hope I answered it.
He said that he's really looking forward to your talk today. So I hope he's watching this. So
he's such an amazing person. So yeah.
Yeah, I remember you both watched each other's talks also last year at the event. So it sounds like him. Then we have another awesome comment for you. You're talented. Keep up the good work. Then follow up with 2 thank you comments and also from Mike.
Yes, if I would, then it would definitely build a lot of quantum computers with the prize money. But I don't think that I am. Yeah, maybe we don't know. Maybe you will as well. Yeah, we don't know.
Time will show. And then Carlos is asking, are interface data with these computers based on electrons on electrons only, or optical also rather?
I don't really understand the question. But if you think, I talked about laser operating the hardware, and if you want to know if you can also use electrons or optical stuff, yes, definitely. Optical is, for example, used for if you use photons to transfer data, and those are, for example, entangled. Then you can use optical systems, and also electrons are, for example, used in ion traps. So in ion traps, you have the electron that can switches between energy levels, and you use the orbitals, which are defined energy levels, to kind of make your probabilities work there. Yeah.
Okay, maybe this is a clarifying comment from Carlos, like an internal solar cell powered by quantum computing. A Tesla does not stop.
I mean, if there's sun and if we are really as good in photosynthesis and scale up the systems like some plants do, then we can, I think, yes, why not? A Tesla powered by some special proteins would be nice from quantum computing. I think that quantum computing itself is like not the quantum computing itself could not be the application for a battery, right? But if we understand how, for example, lithium ions integrate to graphite or something like that much better, we can, for example, also make and expand the lifetime and the lifespan of a battery much better. And the really cool thing is that they actually solved some Schrödinger equations for lithium, I think like last year, 2019 in summer. So that was cool. But I'm not a battery expert. Sorry.
Okay. Mike is helping here to understand Carlos' question. I think Carlos wanted to know how to interface with quantum computers.
I think like at the moment we go over the cloud platform from IBM, for example, and other than IBM, I do not know how you can access a quantum computer if you are not, for example, in Innsbruck. In Innsbruck, they have a quantum computer which you can access if you are at university. Yeah, I think hopefully this answers the question. Yeah.
Okay. We do have one more question that just came in.
Yeah, that's also my favorite question, actually. I ask it all the time because I think especially the question is, if we have to run, for example, a quantum circuit 500 times to get a probability, then what is really, like, is it much more efficient than running it for a longer time on a classical computer? And I think that the efficiency definitely depends on which circuit you use and at which scale you do it. Because if you can simulate it, then maybe it's even cheaper to run it on a normal computer. But if it's getting much bigger, and this easily scales up, because as soon as you add 1 qubit, you need double the computing power. So you can, for example, approximately simulate about 20 to 30 qubits on, I think, 16 gigabytes of RAM. But if you add 1 qubit, you have to double. So you have to have 32 gigabytes of RAM, and then the efficiency is enormous. So at the beginning, not really much, but then as the systems get larger, the circuit's complicated, then there's a quite good gain, I think. Yeah.
Okay, thank you very much. Then questions keep coming in, which is awesome. The cold state needed to use superconductors. Does not it make quantum computers away from being green?
Yep, as I think that quantum computers at the moment are still in the research area. So that's also why I'm not a fan of superconducting circuits. I like ion traps, for example, much better. I think the energy efficiency also comes with if we find better solutions to being less error prone, and if we can find solutions to how we can isolate our systems better despite using enormous amounts of energy. And it depends definitely on the green aspect. I think quantum computers should not be our future if we cannot make them kind of sustainable. Because if we want to move from normal computers because they use too much time and too much computing power to quantum computers, then they also need to be better in every aspect, right? And I think it needs curious minds to find out how we can make them even greener. Yeah, and also how we can make better superconducting materials that maybe do not need as low temperatures as the current superconducting circuits. So there's definitely an area of research, yeah.
Thank you. So here's Carlos. I guess you did answer.
Okay. Okay.
Then we have David tuning in. What do you think about topological quantum computing as now popularized by Microsoft?
I actually prefer the gate model approach, but I think that's because the topological approach is at the moment not as widely spread as the gate model approach. So probably I spend less time with it, and therefore I'm not that keen on it. But in the end, I think topological quantum computing can be much more stable than gate model approaches. And you can also have some feedback loops there, much better than we have in normal gate model quantum computing. So it's actually, I think, a quite good alternative. And we need to find out what our future, we need to play around with it to find out what works best for the future. And it's also cool that like Microsoft works on something different than, for example, Google and IBM, because then we have really much and big companies working on different things, and we can see that in the end maybe it balances out and we have different approaches, yeah, and one works best, yeah.
Good, thank you, Alex. 2 other comments just came in.
Okay.
For you.
Yeah, solar alternating current, yes, let's try. Yeah, that was also the thing about green quantum computers, because if we find better superconductors or better systems, because we find better materials with quantum computing, then we build better quantum computers by having better quantum computers. It's like kind of the hen-egg problem then, and we make better quantum computers by having better quantum computers. That would be cool, yeah.
Thank you. As I'm going to give a couple of seconds of or the chance for people still to ask questions, I'm just going to remind them that now we're going to have a short survey, feedback survey coming up after your talk also on Slido. We collect this for each talk. So how do you like the topic? How do you like Alex? So we can improve from the organizers, also from Alex and Cyrus.
Yeah, definitely. I still can definitely improve, and I'm sorry that the math was definitely a little bit less in this talk than in December. But yeah, please leave any feedback because
No, I'm sure that this was interesting for people. And we also...
I hope so too. Yeah.
We also encourage to adapt your talk, to try different things. This is the only way for actually you to test what people like or what is well perceived.
Yeah.
But then also you never know who's going to be in the room as an audience. Yeah. So sometimes you may have more people who are more into math, sometimes maybe not.
Yeah, definitely. I also think it's kind of interesting because we do not know, like, there's so many cool things going on in general in computer science, and also in every company that has anything to do with data at every point, it definitely has to be activated. Yeah. That I don't know if quantum computing is the answer, but it's one approach. And I think generally, the more we know about every topic, or the more we are aware of all topics that are around here, the more we find a solution to anything. So yeah, that's quite cool. And I love actually the dialogues and the questions, because then I can also learn a bit more about what other people think and what other people like. And I will implement APIs as soon as
And look, another question came in as I was about to stop sharing my screen.
Are we living 1950 version 2.0 in the advent of great development? Great question. I think we definitely live in a really interesting time, especially with COVID-19. I think we are living in an area where suddenly digitalization and remote working became popular because of a global pandemic. So I think I don't know if quantum computers are really the one thing, but definitely they are and help us to find out about other things. And I don't say we live in a version 2.0 because I think quantum computers will become their own version by themselves. And also we can definitely have really cool things coming up. But I think 2050, if we would know what is in 2050, we would be so better off. But the cool thing is that we can still explore, right? Because we do not know what the future is. So the better we explore and the more we learn and kind of embrace, the more we can find out. Yeah, so maybe. Yeah.
Good, and that's actually a hopeful note to end the discussion with. Thank you so much, Alex, for joining us, for always being
Thanks for having me, and thanks for listening. Yeah,
pleasure always to have you. For everybody who is watching us, as we said, the survey for Alex is already on Slido, so you can just rate the talk, and any concrete comment is very appreciated. We'll be back at 4:15 with our next talk, and we're going to the deep learning topic. So make sure you set your reminders, and we'll be back at 4:15. Good afternoon, everybody. I hope you have been enjoying the last day of the WeAreDevelopers Live Week as much as we do, because the speakers we have today for you are remarkable. Like, what a lineup we had so far, and we have 2 more sessions to go before we have to close the whole week and the whole event. Our next speaker, Mr. Koul. He is a noted AI expert, TEDx speaker, and the author of the Practical Deep Learning book. Recently, he joined the machine learning team of NASA as a lead for it. He's gonna tell us the 30 golden rules of deep learning performance. Don't forget to submit your questions and put your comments in Slido throughout the whole talk, and we'll be looking at them at the end. Let's welcome Mr. Koul. Hi, how are you doing? Koul. I'm so happy to have you here with us. Everybody should be seeing you and hearing you right now, so the stage would be yours.
Perfect. Hey, welcome everyone. Thanks for tuning in. If you like AI and you like speed, I think you're at the right session. So I'm here to present the 30 golden rules that you can apply on any AI performance program, whether you are training or whether you are building a production application. It's actually the chapter 6 of a book that me and my co-authors worked on, Practical Deep Learning. So I think I'll just get to the a little bit background. So I've been working in machine learning for about 14 years professionally, and especially in the more modern AI side in production since 2013. And trying to go and build applications, how to scale them up, how to build new product features, or for example, from the HoloLens to Windows to Microsoft Office, to one of the apps which is used by most blind users worldwide after the iPhone. Just going through that journey before sometimes TensorFlow existed, before a lot of the new packages existed, taught us how to make mistakes. And I made a ton of mistakes. And going through that journey, I started preaching how not to make these mistakes, and how something that I had to do, maybe it took me a month, you can do that in, say, about an hour. So they are like, don't make the mistakes and how to do them more easily. So working with my co-authors, Meher Kasam and Siddha Ganju, we eventually ended up writing that in a book called the Practical Deep Learning book, which takes you through how professional developers build applications, whether they are beginners, whether they are startup level, or whether they are Facebook, Microsoft, Google level, taking them through the journey of from the cloud to mobile apps to IoT devices, robots, eventually into autonomous cars. And one of the exciting sides of things is that the last page of the book, it teaches you, how to get to autonomous cars. You build your physical cars, and this is the last page where it says, if you have learned everything so far, maybe you should now actually take it to a real racing track with RoboRace. And yesterday, turns out students at Carnegie Mellon University did that, and they actually are the first North American team to drive a car at 200 miles per hour. So I'm really excited to see how people are learning and going through that journey. The other exciting personal story was that the book is written about Keras, the Keras programming language, which is on TensorFlow, which makes it incredibly easy to train things. And now the founder of Keras, Francois Chollet, is reading it. So that's like what we developers call it, recursion. So now let's get to the meat of it. Whenever you ask a developer what they are spending their time on, usually when they're not typing, it's usually compiling, other than Stack Overflow threads. For AI developers and data scientists, they are not, the most time they spend on is not actually reading, it's not actually even coding, but it's actually waiting for their program to train. Training is the key thing that they will say when they are waiting. And that's very personal to me, because that's the thing I used to do. I used to keep training, experimenting with new models. And the thing that I was basically waiting for was just waiting for it to finish, especially as the data increased in size. And this is a very personal story to me because I noticed in one of the years, the more I was waiting for my program to finish, the more weight I was losing. So I started training a bunch of these programs because there was some production schedule. And for those months, I started losing about like 12 pounds. And I couldn't figure out why, what's the connection between training more deep neural nets and losing weight. And what happened was in my office, there was a pathway. And if I walk on that pathway, it used to take me 2 minutes to go in a loop and come back to my office. And I had tuned my program so that it would also print a result every 2 minutes. So I would run my program, walk around, 2 minutes later to see what the results are. If it's not yet done, I would then walk around for another 2 minutes. And when I would keep on doing, I would basically start walking, 12,000, 15,000 steps a day, and like double the amount of steps I used to take. And I think in summary, the more I would wait, the less I would weigh. Just going through that thing, I learned a bunch of these things I could do to make those programs faster. Exactly the same code, but practically, how can I make them faster? Now, there's a famous person you could ask that, how do I reduce the time I need to wait for my AI programs to train? And he would say,
this is like common sense. The more GPUs you buy, the more money you save. That's right. The more GPUs you buy, the more money you save.
Makes sense, right? The more GPUs you buy, the more power you have, the faster it will train. And this is a great advice, especially if you have a really good boss with a good budget. But as we have noticed painfully in our own lives, what we want is not what we can always afford. And that's the exact same case with AI and machine learning. We might not have the budget to buy the hardware, or maybe the budget that our user's device has, for example, on cell phones, is not as great. But what if you could take that image on the right, that car on the right, and fine-tune the engine, put some nitrous oxide in it, and remove all inefficiencies to get it to perform just like that car on the left. So without spending any money, you can actually start racing like that car on the left. That would be nice, right? And that's what we are going to do in this session. So I'm going to share with you a set of tricks that are practical. So it's not the research world, but things that you can implement, usually from 1 to 3 lines of code. And if you take a basic AI program that you use for training using transfer learning, you just need to keep adding these tricks, and you'll see your programs basically just keep getting faster. Makes sense, right? So let's get on it. But just to make sure that everybody is on the same level playing field, if you are new to AI, the key thing that you want to know is this word called transfer learning. 95% of all work in industry happens with this concept of transfer learning. What that means? For example, if you wanted to learn a new musical instrument like this melodica, and you wanted to learn it from scratch, right? It would probably take you like 3 months to learn this new musical instrument. But what if you already knew how to play the piano? You would just need to fine-tune your skills at playing this melodica, and it might just take you 3 days to get better at it instead of like taking 3 months. And that's exactly the concept of transfer learning. Well, if you want to play, know how to drive a bike, if you already know how to drive a car, I think it's a very common concept. So if you take a data set which is similar to, let's say, ImageNet, which is 1 million images, somebody might have already spent a month training that. Then you just try to fine-tune for your given problem. Maybe it is to detect it's a hot dog or not hot dog, like that Silicon Valley TV show. Or maybe it's to detect what product is going into your factory line and coming out. So this makes training really fast, right? So you don't start from scratch, you use this. And usually how you do it is you take a convolutional neural network. The last layers in a convolutional neural network are very task specific. So all you do is you clip it with a pair of scissors, well, basically in code, and you put in a new pair of layers and you train it, right? So you take something which is existing, published by Google, published by Microsoft, published basically in open source. You basically throw away the last few layers and you put in new layers, and you fine-tune for your given task. You train it for your task. And this is a very common concept. If you are new to it, just go to the link at the bottom and in your browser, play in the Google Colab notebook. And without any installations, without any hardware, you will see how to play that almost on any problem. This will show you how to play for like cats versus dogs and get a maximum accuracy in 30 lines of code. It's simple. Trust me if you get started with this. So now that we are all on the same page, now let's get to the meat of it. You've started with this program, whether you're an expert or you're a beginner, you're at the same amount of coding right now. How do you make this faster? And the key culprit behind slow programs is usually GPU starvation. So usually what happens is people, when they train a program, using any, when they start with an AI program for training, the program usually loads data from the file system. It then pre-processes it, resizes it, it maybe does some augmentation, and then it gets a bunch of these files ready in a batch and then passes it to the GPU. So the GPU was waiting for the CPU to pass it all. And then the GPU does this training, what it's really good at. And after training for one batch, it then tells the CPU, I'm done, give me the next batch, right? And the CPU is waiting all this time. So all the stuff that you see idle in this image, we don't like that, right? This is basically wasting your expensive hardware resources. So what we want to do is figure out how to make this entire diagram basically black in color instead of having those idle states, because you paid good money for your hardware. So let's make that fast. So we obviously, before we start optimizing, we need to know, are you actually being efficient? Like, how do you test that? So we need some tools to know that if you are getting efficient, or are you still, wasting your resources? So let's look at some tools of the trade. There's a very nice tool called TensorBoard Profiler, which is basically allowing you to debug and see how your hardware, which part of your hardware is being actually actively used. So in this example, when you see, this is basically opening in a web browser, where it's showing that, hey, from time t 0 milliseconds to this point, it's using the CPU, and then the GPU starts, right? Easy to see, running in your browser, great. And very visual to see. You can actually dive down into a couple of milliseconds deep down and see all this. And all you got to do is, in your normal program, simply make a callback reference, which will start this in a web browser. Now, there is still some little setup, but this is a tool that a lot of advanced users usually use. Maybe you wanted something even simpler than that. Maybe you just wanted something where you can just run something on the terminal and get to know. Maybe if you can't access the web browser there, right? So there's something actually even simpler than this, and this is called NVIDIA SMI. So NVIDIA SMI, or the System Management Interface, it will tell you, how hot your GPU is getting in Celsius, the wattage, the power it's consuming, how much memory your GPU is consuming, and more importantly for us, it will actually tell us the GPU utilization. So here it's saying, when I ran this thing at that particular millisecond, it was 51% GPU utilization. My GPU costed about $1,000, and when it was latest state of art. And if it says 51%, I'm basically wasting $500 worth of hardware resources at that time. We don't want that. So we will we want to reduce that. And by the way, because I said it ran it at that millisecond, you can actually write watch command and give it run it every 0.5 milliseconds. And literally you will see this repeating and streaming on your command line, and you can see it go up and down based on when your program is running. So let's now really get into the meat. There are various parts of a deep learning pipeline, and from preparation of data to reading to augmentation, training, and then inference. So let's attack it, in different stages. So we have some more, we just don't go haphazardly going around. So let's attack data preparation. There are two anti-patterns in software engineering when you are dealing with data, which also applies to deep learning. The two anti-patterns are that you don't want thousands of tiny files, because there'll be too much overhead in seeking these files, right? But you also, at the same time, don't want one gigantic file, like let's say 300 gigabyte file. As anybody who has tried to download files, a single file like this is just havoc. And the same thing with reading it. If you have like one gigantic file, it's harder to parallelize reading that, especially if it is over network calls. So a sweet spot is that how about we serialize this file into 100 MB files and just keep them on disk so that they are just more efficient at reading. Makes sense. So you can actually save this as TensorFlow record files. So that's the first rule we'll follow, and we'll see it in code. The second thing is that sometimes you do a lot of processing of the data, and every time you have to read that data, you have to redo that processing again and again and again, right? How about we don't do that? So instead of having to repeatedly do the computation again and again, how about we do the computation once and then dump it down on your disk so that next time the data is as freshly available for reducing the computation as possible. That sounds like a good idea, and we'll see it soon. Finally, a lot of times, developers want to use data, and they will go and download this gigantic open source data set. If you're trying to solve COVID right now, or if you're trying to solve ImageNet, trying to download that gigabytes and gigabytes of data, you first download it, you format it, you then try to figure out in Python how to read it. That will easily take you a week of time. But how about you could make a high performance pipeline in literally 5 lines of code? And that's what TensorFlow datasets package does. So for example, here I wrote TFDS as a function, and it has a bunch of these datasets already available, including this X-ray dataset of the chest that you could use personally for starting with a COVID-based training set. And it just takes 2 lines of code, really, to make a high-performant pipeline. So somebody has already done that job for you. So I think I would recommend you to start with this if it's not your own dataset. But if not, I think we can go next. So, all right, if you can get till here, I think you're already pretty efficient. By the way, if you want to become famous, I have a hint for you. Collect a dataset and publish it back in TensorFlow datasets. And what will happen is others will start to cite your work, and suddenly you'll start getting viral fame on Twitter. So, free tip. Alrighty. So now that we know how to process the data before even we have to run it in our pipeline, let's look at how you read the data. And if there's one thing that you want to repeat after me, it is TensorFlow data pipeline. So tf.data is the way to make high performance training pipeline. And in the next 5 or 7 slides, we will iteratively show one line of code after another and basically make an entire pipeline that will keep getting faster and faster slide by slide. So just hang on with me on this. So for example, I was mentioning previously that, hey, we like to read data in TF record format. So all this code is really doing is reading that data in TensorFlow record format. It's shuffling the data because you usually want to, do some randomization. And then that runs through a bunch of functions and then batches the data. You can, use that as a reference later on. So let's look at how to make it even faster. Well, first of all, you don't want to do that GPU waiting for the CPU because of asking for the data, and the CPU is then waiting for the GPU to finish computation. So a really good idea is that how about we put a buffer for the CPU and put a buffer for the GPU. So the CPU keeps running, and as it's getting the data, it's basically just putting it in a buffer for the GPU to read at a later time. And similarly for the GPU, having that buffer that whenever the training is finished, it's putting the weights back to the CPU, right? And you can do this asynchronously. Pre-fetching is a concept for most software engineers in their normal pipelines, and this you can do in AI also. So all you need to figure out is what is that right buffer size, and you are golden. Imagine writing that single line of code and literally watching your GPU efficiency go from 50% to like 80%, right? That would be cool. And you can do that now. Similarly, you want to use all those parallel CPU codes. Why just keep it to one single thread? So you can also parallelize CPU calls with literally a single line. All you have to experiment with is how many is the number of codes you have on the machine. Do that. Well, if you can parallelize CPU calls, well, you can also parallelize I/O, right? Especially if you are reading something over a network or over like a spinning disk. So similarly, you can use the interleave command and do that. Nice. In deep learning, most of the people don't want to read the data one after each other. They want to randomize it eventually. Ironically, most deep learning pipelines still read the data one after each other. And imagine you have like one gigantic file and other tiny small files. This gigantic file will basically keep your queue stuck. So you can use this non-deterministic setting in here to basically say, hey, files, whatever order they come in, just give it to me. And suddenly you start to notice things often getting faster if there is imbalance in the data. Obviously, caching makes things faster, and same is the case. You can cache the data in your RAM if it fits, and you'll start to notice again things getting faster. Takes one line of code. There are often some experimental optimizations that are not available in production. So just like Google Mail has all those experimental options which eventually become production features like Smart Reply. Similarly, you can see this months ahead of time and see what works for your case. And finally, I was mentioning all these numbers that you have to tune. You have to tune it for your particular hardware. But maybe you're trying to then run it on a cloud system. Maybe you're running on a different machine. Maybe you're running on a cluster with different kinds of machines. Tuning this will again become a messy thing. All you got to do is forget about it. Just run this auto-tune parameter. Behind the scenes, it's running something similar to reinforcement learning to tune for your particular piece of hardware and come up with those values that are optimized for you. So if you're noticing how things are basically getting simpler because now AI is working hard to figure out how to tune your AI program. So if I just count all these things, when I started with the first slide, I'm here reaching and putting all those examples in one single slide. So just take your camera, take a photograph of this, and copy paste it in your pipeline, and suddenly you'll start noticing your programs are getting wildly fast. And good job if you have reached so far. All right, this is nice, but you can do more, right? And one of the key places is, what can you do so my CPU is not my bottleneck anymore, right? Because maybe your GPU is just too fast. So turns out, when you, let's say, train a hot dog, not hot dog classifier or a cats versus dog classifier, you have to read images. Maybe these are like high resolution images, so you have to resize them, right? Maybe you have to crop them. You then want to rotate them to kind of, augment. That's called data augmentation. And this is basically data pre-processing. It's pretty elaborate. Now, apparently what happens is that a lot of the packages that you use, especially like Keras, it does all this augmentation in the CPU. And that can be a source of bottleneck. OpenCV, Pillow, all these built-in augmentations sadly still use CPU. What would be nice if you could do all that using the power of your expensive GPU, right? So that you can make full use of that power. And that's what we'll do. Instead of using the inbuilt augmentations of Keras, we'll just start changing it so your data pipeline can now use inbuilt augmentations in TensorFlow itself. So this command basically is inbuilt inside TensorFlow. And if you use this, it will actually start to do all these augmentations within the GPU itself. And that is good news. You can change the hue, you can rotate the image, and you can do a bunch of these things, increase the brightness, play with this. One thing I will say is that it's still a bit limited. You can't do every augmentation. So that's one way of doing it. The other way is that NVIDIA actually has a package. So whether you use PyTorch, TensorFlow, or whatever pipeline you use, it will literally help you build that pipeline using something called NVIDIA DALI. And best part is that it will take that data and literally do the JPG decoding inside the GPU. It will resize inside the GPU, augment inside the GPU, and it's built for the best performance. If you have an NVIDIA GPU, it's built by NVIDIA, it kind of makes sense. In fact, NVIDIA used it to break an industry benchmark where they trained ImageNet in under 80 seconds. This is like 1 million plus images. They trained a ResNet model in 80 seconds using this. So proof is in the pudding. Alrighty. So now we know how to read the data nicely. Question is, can you train much faster, right? Like that's where the real meat is. So let's go over a couple of tricks that you can use. One of the key things is using this one-liner and suddenly noticing that you are getting 2 to 3 times faster performance. Like that would be nice, right? So imagine this for a second. All the weights in your program, when you train a deep neural network, these are stored in 32-bit floating point, right? 4 bytes, 32-bit. What if you could reduce it down to 16 bits, right? And do 16-bit arithmetic there. Well, that means that you'll suddenly have half the size of the model. So in your GPU bus, you are basically now able to send 2 times more amount of data and 2 times more amount of the model weights. That would be great, right? And if you actually have to do that properly, it's really, really hard to code. It will take a long, long time. But what if somebody has already done it for you, and all you got to do is go to the top of your program, where you write your import statements, and literally write this OS configuration. And what Google noticed in some of its bigger programs that it was actually starting to get 2 to 3 times faster performance. So just do that. Alrighty. The other thing you can see is, when we are playing with that GPU utilization, your GPU has some amount of memory. For example, let's say 4 GB, 6 GB, or 12 GB of memory. Now, imagine you are reading a 1 million data set. You're not going to load 1 million images and train on it. No, you just don't have that memory. What you would do is maybe try to load 8 images and train on a batch of 8 and keep doing that. But maybe you just happen to have more memory. So you might want to go and now try 16 images in a batch. And maybe you still have more memory left. And the point is you are basically reducing by increasing the amount of batch size, you're reducing the amount of I/O you have to do in loading it. So if you play with increasing the batch size, as you notice here, the red line is showing that the GPU utilization started to increase. So I kept increasing till my program crashed. So I came up with the conclusion that, look, I just need to find the value which is one right before my program crashes, and I'm good, basically, right? So what you can do is, maybe take like a number like 32 and just keep increasing in multiples of 32 till your program crashes, and just take that one last value. And as you can see on the left-hand side, the time it was taking for my program to train per batch, it actually started to decrease from 100 seconds to like maybe like under a second. So on a MobileNet model that a lot of people I would recommend you to use, MobileNet V2, my GPU could use 800 images, and that's kind of cool. The third thing, which we learned using a case study at NVIDIA, was they were training a program, and they noticed that as they tried to tune these batch sizes, if they took an odd number, they would notice that if they took multiples of 8, they started to notice 5x increase in performance. And something impressive was happening behind the scenes, that they were less efficient before, and now they started to get more efficient. And what was happening was, as we went from CPU to more specialized hardware like GPU, and then more specialized like TPUs from Google and Tensor Cores from NVIDIA, they have defined sizes of how to do that numeric multiplication. And they have some minimum requirements for their hardware to be able to use those Tensor Cores or TPUs. And one of the hard requirements is that for Tensor Cores, for example, the numbers need to be divisible by 8. For example, the number of convolutional filters inside your model, the size of the batches that you're using, and a bunch of other things. So the key takeaway from me would be that use batches of 8. In fact, a better recommendation would be, for NVIDIA, use multiples of 64 or 256 if you have that specialized hardware. For Google TPU, use multiples of 128. But as you're noticing, your guessing is reducing if you literally start using these golden rules. So go for it. The other thing that every person who have to play with AI while training would be, there are certain things that you have to tune now. And one of the key things that you have to tune is that learning rate parameter. So usually what happens is, if you take a very tiny number, like let's say 10 raised to power minus 5, you have as a developer to come up with that number. I think the default is like 10 raised to power minus 4. If you take too small a number, it will take a long time to come up with that optimal answer solution for your problem to get to that high accuracy. And similarly, if you come up with a really high value, like let's say 10 raised to power minus 1, you might overshoot the minimal solution which is at the bottom here, and then overshoot and keep going around and around and around. You don't want that. You want some optimal value in the middle. And there are many ways you can do it. You can go brute force, you can try multiple things, you can waste a bunch of items, or you can go to GitHub and download this library called Keras LR Finder, right? It implements a research paper which called Cyclic Learning Rates by Leslie and Smith, which will do that job for you. So in this example, I'm literally using that library to plot my learning rate and my loss function, and then the rate of change of loss. And whatever that minimum value you get here, in this case, it was 10 raised to power minus 1, you just copy that value and literally put it in your training code, which you get from any boilerplate code, like I shared previously. If you do that, your program is gonna end up training fast. So it's not about GPU utilization anymore. It's like just selecting the right parameter. The last few things I will mention, and this is probably the last piece of the code side, would be, when you work on C, you compile your program and it runs really fast. And then if you code in shell script or like PHP, it's like running it line by line and interpreting it, right? So when we went from TensorFlow 1.0 to 2.0, to give people the power to debug more, it gave the power to run things line by line, but there were certain potential overheads because you're not compiling the entire graph in one go, which is more visible if you have something with a loop and like a tiny operation. So the key thing I want you to learn from this is just write that @tf.function on top of any function that you have in TensorFlow, and suddenly see magical speedups. So for example, here, I literally wrote a simple function here, with like a single layer, nothing literally. And then I copy pasted that same function and literally wrote the tf.function line on top of it. I ran it, timed it, and I noticed a 10x speed up. The only difference between the two pieces of code is that here it's compiling it in a graph and running it. So it's doing all the optimizations for you. So if you can get 10x speed up for something small, why not do that? I hope you are appreciating the fact that if you start joining all these tips, you might actually have much faster performance. Finally, it's something for data scientists. One rule that I can't find a name online, so I'm just coming up with one. It's overtraining a generalization. So let's say you wanted to learn French or Spanish. Option A is that I give you a dictionary and you start reading it word by word and trying to learn it, and that will take a long time, right? You probably won't even be confident. The other way is that I give you 50 common words, the most common 50 words to learn. You learn them, you get confident, then I give you 100 most common words, 200 most common words, and I increase your thing. And every time you start getting more confident, at that point, I give you more words so you can still learn things you're bad at and keep getting better. And you can do exactly the same in deep learning. For example, we can, instead of giving you 1,000 classes for ImageNet, how about you just pick 10 classes and train on 10 classes? And when you start seeing you're doing good, then you increase to 20 classes. So 30, 40 classes, 50 classes, 100 classes. So you train 10 classes, then fine-tune for 20, then fine-tune for 50, then fine-tune for 100. And you'll notice that suddenly you're actually reaching your accuracy faster, but you also notice if you are making mistakes. That's kind of good. Similarly, if you want to do augmentations, maybe don't even augment at the start. have zero augmentation, just train your network, then start to rotate, change the colors and all that. Similarly, Jeremy Howard from Fast.ai, he calls it progressive resizing, where instead of taking 224 into 224 resolution, how about you take like one, like if you half the size of the height and width, that's basically 75% less data, so you get 4x speed up. Similarly, if you take quarter of the height and width, you get 16x speed up. So start with quarter height and quarter width images, train on that, then half height, half width, then full height and full width. And what you'll notice is that initially the program is learning broad shapes, broad colors, high level details. And then when you start increasing the resolution, it starts to learn these fine details. Very good things, other things that you can do, which literally take one line. Install an optimized stack for your hardware. I mean, this goes without saying it, right? Instead of using hosted binaries, which are supposed to run from Raspberry Pi to the most powerful computer, let's build specific to your instruction set for your particular machine. So that's one option. Or maybe if you don't want to figure that part out, you can just go and use Anaconda. Anaconda will install, for example, the more optimized installation. So for example, if you use a Xeon CPU, Anaconda will automatically install the more optimized deep learning TensorFlow version for your particular hardware. And you might actually notice 2 times speed up using that for instance. So that's kind of cool. You can also do things. For example, you can tell TensorFlow, hey, these are the number of CPU threads to use based on how many, number of CPUs I have. Use that. Similarly, you can also tell it the number of cores per CPU you have and see this thing working faster. And just literally line by line, as you start adding, you start seeing it getting faster. Obviously, this is all so that you could turn Mr. Bean's car into a race car. But maybe it's just time that you have done all this and you want to go even faster. So one option is you can go and buy a nicer piece of GPU hardware. For example, this DGX2, it costs $400,000. It consumes the power of 7 air conditioners, and I think it's like 300 pounds of weight if you want to do some weightlifting. So you can do that. In fact, 2 weeks back, NVIDIA announced the NVIDIA A100 chip. A single chip and a system, the full system cost $200,000. That previous system had 16 GPUs. Can you just imagine how much this would cost with 16 of them? There are systems which actually cost way higher. So that might be one way to convince your boss. Or there's another thing you can do.
Work with me here. The more you buy, the more you save. That's right, work with me here. The more you buy, the more you save. This is not a complicated talk.
So, you could show this clip to your boss from the NVIDIA CEO. And going on this, if you have multiple GPUs, why not, use them? Or how about you go to the cloud, AWS, GCP, Azure, and basically get a bunch of virtual machines and start training with these virtual machines. If you take this piece of code and have a few virtual machines, you'll actually notice literally linearly proportional scaling up, depending on if you have just single nodes if you have a single node with multiple GPUs, or you have multiple nodes with one or more GPUs. You can decide which of these strategies to use and just plug it inside this particular code. I mean, can't get simpler. By the way, Uber has a program called Harvard, which you can run your particular Python script, and it will do that job for you, which is to scale it onto multiple servers for you. So that's another thing you can do. By the way, if you want to learn more on can we do even better, maybe you are a developer like me with not much money, and you can go and fight. You don't have the Google budget or the budget NVIDIA has for training some of these large programs. Well, we as individual developers still have a lot of power. So you can go to this site called Dawn Bench, and here people are basically fighting for the cheapest amount of money they need to spend to basically get a faster program running. So for example, Alibaba released this particular, in this experiment, that you could train entire ImageNet with $7.43. That's kind of cool, right? For example, this is, the source code for this is available here, where somebody could use Lambda GPU Cloud for $19 or the GCP for $12. So why don't you just go click on the source and just copy it for your programs, right? This is all previously optimized. You could also fight, there are also some fights on who can train it fastest. So in this particular example, teams from China are showing that they can train an entire ImageNet in 2 minutes 38 seconds. I mean, that is cool. Few years back, this used to take months. In 2012, this used to take months. Right now, it's taking 2 minutes. Like, how cool is that? And we should just learn from this. In fact, there's a performance benchmark called MLPerf, which is a more industry-based benchmark, which is for hardware, which is to measure the hardware performance. And this is where the big wigs fight. And for example, Google made an entry for 1.28 minutes for training ImageNet. Obviously, it costed them 1024 TPU accelerator, so that is pretty expensive. I think this would cost somewhere in the range of like $35 to $40 million of hardware. But you don't care about that because you can go to the cloud and literally rent these GPUs and maybe get done with literally $7. I think that's the key take-home story. So you turn the GPU cloud for a few minutes, train your thing, scale it to 64 nodes, and then kill it and just spend a small bunch of money. So it's complimentary to mention last week, Microsoft said that it came up with a supercomputer with 10,000 GPUs and 285,000 CPUs. And I was predicting that OpenAI would be training their language models. And a few hours ago, OpenAI released this thing called GPT-3, which takes more than a terabyte of memory just to train, and it's about 1,000 times bigger than some of the largest models in 2019. So you can see that with more power, you still have the power to do more computation, but if you can just rent it out, I mean, that just makes everybody's life easier. I'm going to, have 5 minutes left, so I'm going to end it soon, but I just want to give you a very sneak hint onto inference. So let's say, you are building something for mobile phones, or you're trying to run something performant model on servers. So the world of researchers is basically trying to come up with the biggest, baddest model, which takes a ton of, they usually take, a few megabytes, 100 megabytes, 200 megabytes. In fact, the most common model still used by most people is in the range of 100 to 200 megabytes, but that's too big. You can't ship that to a production mobile phone, right? So most developers like us are more concerned that it needs to run fast. So we want it to be accurate, right? So we want to be higher on this graph, but at the same time, we want lesser number of operations. So we're really looking for the sweet spot somewhere in the left side of this, right? As Marie Kondo says, does that 500 MB model spark joy? Probably no. So you can go to this website called paperswithcode.com/SOTA and start looking for what are those models that are actually at the top of the list, but also which are still optimized. If you look at this paper, the key thing I would want you to get from this is, because you're going to use transfer learning, which is 95% of all AI problems, pick these two, which is MobileNet or NASNet Mobile. So as of today, MobileNet V2 and NASNet will transfer for your problems really well, and are also small enough that they will be, shippable, about like 15 MB of size, I guess, for MobileNet V2. Similarly, based on the problem you're working on, for example, if you're working on object detection, right, making those bounding boxes, you can find a model from Efficient-Det. Again, all published in open source. You just need to pick something which for your user, if depending on it's a server or a mobile phone, you can pick that number. Remember that if you ship something on mobile phones, you have to support about 4 years worth of hardware. So you need to pick the 4 phone which was published 4 years back and still be able to run it in real time. So you might want to go, as much left as possible. Similarly, for NLP models, as I mentioned, the size of these models keeps increasing. And in fact, Microsoft released a model with 17 billion parameters, and OpenAI last night released a model with 175 billion parameters. But if you're going to production, I would tell you to just use this thing called distilled BERT, which is like 66 million parameters, and it gets the job done without as much loss in accuracy. So that's the key take-home message. The other thing would be to use something called model quantization. So that was the part I mentioned to you, which was converting 32-bit point operations and reducing the number of bits, so that if you reduce it to 8 bits, it suddenly becomes 1/4 size of the model, and you are a quarter of the size, right? So we did some experiments and found that even if you go to 8 bits from, you can still effectively retain 98% of the accuracy, and that's good. And in most packages that you use, whether you use CoreML for iOS, whether you use TensorFlow Lite, you have these operations available, and you would be there for the win. I'm going to, at this point, end my talk, and you can use these slides for reference. But the key item I want you to learn from all this is that you can join these tips all together in one place with whatever you are doing. Effectively, you could do it even in PyTorch, depending on the equivalent statements in there, or you can copy these one by one and just see your program getting faster and faster and faster. And when you don't have to ask for getting more bonus GPUs, you can instead ask for getting the bonus for your paycheck. So that's all I have. Thank you for attending this talk. And in case you want these slides, hey, WeAreDevelopers, so you can just email wget-presentation to practicaldlbook@gmail.com, and I think you'll get the thing you'll get is all these rules in a single printable page, which you can stick on your fridge, on your desk, on your boss, wherever you want. So I hope you enjoyed the presentation, and I'm looking forward to all the questions that you have. So thanks for attending, and looking forward to hearing from you. Thank you.
Thank you so much for the presentation. It was really entertaining, and I'm sure that people loved it as well. There are already some questions on Slido, so I'm going to go ahead and share my screen as well. And
Lovely.
meanwhile, remind everybody that they can still submit their questions on Slido with the code LIVE2020. So you should see also right now what's coming, what we have submitted already. So the first couple of submissions are more like comments, awesome tips. I have to read your book.
Thank you, Coder.
So this is definitely a great feedback for you.
Thank you.
Then awesome insights. And that was a question that's here. So I want also to remind people, you can vote questions. So we'll go through the questions that you like the most first. And let's start with the first one. Yeah. What would handle highly imbalanced data to escape the bias problem? No way to generate new additional data.
Yeah, great question. One thing that I have found useful is you can do a little bit of playing with the data, so that when you're training a particular epoch, at least in that particular epoch, the data sizes are slightly more balanced. So you would basically have to, undersample from some of the bigger things, and in the next batch, feed it. A simple way to think about it is that if you have, let's say 10,000, 100 images of dogs and 300 images of cats, what you can technically do is basically copy that 100 twice. So right now you have 300 images of dogs, but with duplicates, and 300 images of cats, which was the original. And now with augmentation, just let it train. And with that balancing, it kind of reduces it a little bit, the bias in the particular system while training. but with augmentations, it kind of evens out. So there's no great answer to this, but I think just oversampling the lower thing and undersampling the higher thing and running augmentations hard will be a good way to go about it.
Thank you for your answer.
By the way, I'll quickly also mention, you can set in certain ways that augment my duplicates more and augment my original data less, like, with the higher number of classes. So go for it.
Okay. Mike is asking, how do you personally draw the line between efficiency and effectiveness?
Lovely, lovely. So usually whenever I'm starting with like solving a problem, I just take boilerplate code from whatever website. I just copy it from GitHub or like from the book and just run it on my machine. And when I'm first running it, I'm just literally trying to see, is this program even running? Right? Am I even making a mistake? Because I didn't want to make a mistake and waste a month of my time. But once I really know that, okay, it's starting to run, and then I need to keep experimenting, I'll have to wait for the program to keep training. And that's where it becomes really, really hard. So that is why these tricks that you are seeing are literally one line. You just need to, like the sheet of paper that I was talking about that you can get, you can literally copy paste that code. And it's not much. You just have to write it once. You don't need to remember it. It's just like a checklist that you check one line by line, line by line. And because it's not too much work, you can probably follow like the first 10 tricks in 10 lines of code and get done with it. Now, then what happens is, let's say, now you're starting to train ImageNet level stuff, which is going to take you a lot of time, like, a week, let's say. That's where, you really want to make it more effective. You want to make it more efficient. So depending on how big your data is and how long you have to wait, maybe 5 minutes of coding time might save you a couple of weeks of real time, which most developers sadly learn after going through that journey. Thank you for asking, Mike.
Yeah, so that's an important point there. So you can save yourself some time. If you have to pick Keras and FastAI, which one would you pick and why?
Yeah, great question. So Fast.ai is great for learning, and that ecosystem is increasing. It's built on top of PyTorch. And Keras is now really well integrated in TensorFlow. So it's not a question of like A versus B. It's a question of, what are you trying to build, where you are going. I mean, both are mature systems. I just personally saying, just because of the vast TensorFlow ecosystem and just that whole interoperability, let's say if I have to go and ship something for, let's say, an iOS application, I can go and download this thing called Fritz. Fritz.ai. I can get that library, literally put a callback function in my Keras. And as a developer who knows literally not a single line of mobile code, I can deploy a model in their open source app. And imagine I had users, I can actually deploy this to 1 million users. Like, how cool is that, that I, who doesn't know mobile programming, can actually do that whole deployment cycle and reduce the amount of work I have to do as a data engineer. So for those reasons, I usually tell people that, hey, be good at Keras and TensorFlow system for production, but don't discount the others. Like, definitely learn the others. We are developers, we keep learning, and we just have to be malleable. So be malleable.
That's a great advice. Another question, you mentioned quite often NVIDIA, but can you apply those tips as well with an AMD card?
Yeah, good question. Look, I'm not a salesman for NVIDIA. It just so happens that NVIDIA took that bandwagon of realizing that GPUs are really great for AI, and that's where their stock is also going. Now, all the packages, if you see, are based, to be run on CUDA. CUDA has these primitive functions already built in, and that's why all deep learning people usually use NVIDIA-based programs. Now, AMD has also something going on. For example, you can download a version of TensorFlow called TensorFlow ROC. TensorFlow ROC, which will actually accelerate it on AMD cards also. So that's one particular option you have. I will also flip it to you and instead ask you, you can actually even train this on the cloud, let's say on Google Colab for free, literally. You can buy $10 monthly subscriptions to Google Colab Pro. See, Google is not paying me, but I'm telling you that. Or you can go to Azure, you can go to AWS, and you have these options. You can go and get Kaggle kernels and do it for free. So you have these options if you are bound by just having an AMD card, and that way you can get more acceleration for free sometimes.
Thank you for your detailed answer. Next is a question about the slides.
Yeah.
You already mentioned where they're available. We can also share the information on our Slack channel for the event, so people know where to write to you to get the slides. So we will definitely.
I'll post it on the Slack channel, and very simply just write wget presentation in your email subject and email to practicaldlbook@gmail.com. I mean, technically, all these slides are basically from the text of the book for more details, but I'll send it over. Thank you, Jaka.
Suggestions on becoming a better deep learning practitioner.
Yeah, building projects, building real projects. So for most people, when I've been guiding, so I needed people to join my teams, software developers who don't know AI. So I would tell them, hey, come and work with me. I'll teach you the practical side. Like, you don't need to get a PhD. You know, there are like few simple things that you need to do. And that's how do you scale this thing? How do you, work on problems in a range? How do you reduce the model size? How do you measure the heat? How do you measure the battery power if you're building a robot or a mobile phone app, or even the, like on the browser? So I used to, tell them about it. And the one common thing I found is build a showcase project. That should be your motivation. Like there's a way, you can first build a project. As you're building, learn the theory around it, and then go and do the deeper theory eventually from Coursera and all. So the book is actually written as a motivation first for developers. So you take a practical problem which Google is doing, and then you replicate it as a newbie. You then replicate it as like a startup engineer, and then you replicate it maybe like a Google, Microsoft, AWS engineer. So you have different scales, different talents. And by building these projects, you will then start to really appreciate, okay, if I had 1 million users, this thing is not going to run in under 500 milliseconds, which is my latency requirement. So go build these projects, and it helps you also get into the interview. So make a diverse set of projects, some for computer vision, some for NLP, natural language processing. And I think if you can cover these two areas, there are really fast ways of getting started on these. Definitely try with Keras. For NLP, you have PyTorch transformers from Hugging Face, PyTorch transformers. So definitely become a master of that. And the secret, which most people don't realize, is that these things usually take like 5 to 6 lines of code to do these days, because it's abstracted so well. I should also really mention that the power is not just in knowing how to train, but how do you productionize it? Like, you have to put it on a server someday. So the easier you are, getting better at how do I put it on AWS, on GPC, on Azure, and building that API. All these platforms already have easy ways for you to build a production quality API so you can scale for it. Like Azure has Azure ML, AWS has SageMaker, GCP similarly has their whole GCP cloud thing. So if you use that, you can see the latency of the models there, and you say, okay, I'm actually getting just by getting this practice. So go out there. You can email us at the email address I said. If you need some mentorship, it's practicaldlbook@gmail.com. More than happy to be there if I could be of any help. Thank you.
Thank you as well. We do have 2 minutes time, so we can go maybe shortly through those 2 questions. You can choose which one to choose as.
I think we can cover all 3 quickly. So what would be nice to see in TensorFlow 3.0? So there were a lot of pain points in TensorFlow 1.0. With every good thing comes bad things. You learn from the bad things. I wouldn't say bad, but just hiccups along the way. And TensorFlow team did a great job going towards 2.0. I think more openness with ONNX. So the world is going towards openness, right? You don't want to be in one place. So ONNX, which is a partnership originally between Facebook and Microsoft, is like the common model format. And you'd be surprised to see that you can actually run some of the models from TensorFlow on Windows laptops. It was just announced, or like from PyTorch transformers on a Windows laptop, faster than many of the like for the same benchmark that we have previously seen before. So using ONNX and interoperability with that would be a common theme I would want to see. Although the converters are already available, so that would be one. I'll let the TensorFlow team answer some of these. So the next question is, what is the current project you're working on? I'll give a shout out if you are a developer. I'm working with NASA FDL as an ML lead, and they're looking for people who have some AI knowledge, who have some showcase projects, to come and work with space scientists for 2 to 3 months and solve problems for the space. In fact, my co-author, her work ended up discovering a comet, and yesterday it ended up discovering 2 meteor showers, which was using AI. So if you have interest, just search out NASA FDL, NASA.ai, that's what you need to go at. I'm also working on the 200 mile per hour autonomous car, which was the last page of the book. So that's exciting. Thank you. The last question is, great talk. I'll say thank you. Thank you, sir. Or thank you, ma'am. And you showed quite nicely how to find the optimal learning rate. Is there something that tells you a model is complex or yes? It all depends on the data, and it all depends on the model. You just have to tune it. Sometimes the problem is easy, sometimes the problem is hard. But I think the joke is that 10 raised to power minus 4 is the best learning rate ever. So I just go with that to start off. Thanks for asking, and I hope you enjoyed the session. And I'll hope to see you on Slack.
Yeah. Thank you so much for the talk. As you see, everybody was really interested, very engaged on Slido. If there are any more questions that come in, we'll make sure we forward them to you so you answer them in a blog post or on Twitter, like another way. Thank you for your participation. I hope we see you soon again on one of our live events, or even better if physical events soon. So I wish you a great, I think, day ahead, like as you are a bit behind us on the time zone. So yeah, we will be back at 5:30 5:30 with our last talk for the live week, everybody. And I know this may make you a bit sad, so that's why I want to tell you about 2 events that are coming up from 2 of our community partners. So next week, you actually can join the Entrepreneurship Avenue Conference on the 2nd of June, starting at 4 p.m. Central European Time. And this is a conference for students who are interested in the startup ecosystem. A lot of good speakers as well, not so technical, but still they have been a really amazing partner of ours. So we always want to support them. And they have really thought leaders in their fields as well, who will be talking there. And then another huge event coming up on 10th and 12th of June. The Women Network Global, they have a goal and the ambition to unite 100,000 women, minorities, and their allies in tech. So they have prepared keynotes, engaging panels, workshops, so a lot of good content packed in these 3 days from them. You may have already seen this all over social media. We want to support them, so if you're interested in a really good technical conference content and also want to support women in tech, make sure you join the event as well. And yeah, with this being said, we'll be back in 10 minutes with our last session for the live week. Anirudh, thank you so much for joining us. And everybody, you should be also seeing the feedback for Anirudh right now on Slido. So we always appreciate the input. We'll
awesome.
see you in 10 minutes. Bye. Thank you.
This time for real.
Okay, everybody, we've come to an end almost, as we have our last session coming up just in a couple of seconds. I just want to remind you that right after this session we will have a symbolic closing ceremony here in our office, so make sure you stay tuned to hear the wrap-up, to hear what you should expect next from your developers. And now I want to thank you for how active you have been during the whole week on Slido and on our Slack channel, and really tell you that we appreciate this, because this gives us a strength, this gives us feedback and really pushes us, gives us energy to continue do what we do. Our next and our last speaker, actually, it's a new face for the WeAreDevelopers stage, and we were so excited to welcome her in Berlin this year, but we cannot, so we're welcoming her online. Boonstra, developer advocate at Google. She has taken throughout her years through her experience roles in engineering, tech trainer, project manager, product manager, so her experience is really deep. She will talk to us about conversational AI. And I just want to also mention that she has a book for O'Reilly with the name Hands-on Sencha Touch 2. So as you can see, really complex and interesting profile and experience she has. I hope you enjoyed the talk. Make sure you're still active on Slido for this last session, and we'll be back after this.
Welcome everyone. Today I'll talk about implementing a custom voice AI so you can create your own voice assistant. And we will do this by using WebRTC to stream voice from a browser microphone to a backend server, and the backend server will talk to certain Google technology and then return an answer. My name is Boonstra. I'm a developer advocate at Google, and as a developer advocate, I'm responsible for conversational AI. So this means like chatbot technology, like Dialogflow, but it also means speech technology, speech APIs, speech to text, text to speech, and technology in contact centers. What is an AI voice assistant? Well, that's a piece of software that can run for an individual and then based on commands and questions, and then return results through human voice by synthesizing the text to speech. Why would you create your own custom voice AI? Why wouldn't you use the Google Assistant or Siri or Alexa? This is not a talk about the Google Assistant, but you will hear me referring to it a couple of times, because there are here some facts that you just want to be aware of. The Google Assistant, for example, is publicly available, and that is a great reason if you are a brand and you want to bring your brand to the larger crowd, because there are so many Google Assistant devices or Alexa devices. That's great if you can deploy your apps too. Maybe not. It runs across all Google Assistant devices. That means the Nest Hub. Previously it was known as the Google Home. But it can also run in Android phones and tablets. It can even run on iPhones through apps. And with the Google Assistant, you get like all these native features. For example, you can ask the Google Assistant certain questions and you get answers for. You can ask the Google Assistant to turn off the lights. If you have it connected to third-party hardware, then it will be like a smart IoT house. But you can also communicate with apps, and we call that in the Google Assistant ecosystem actions. It's part of the Actions on Google framework. And to open such an app, you need to invoke it by using certain Google wake words, like, for example, hey Google, talk to my app. And then your app will be deployed on the Google Assistant ecosystem, and so are millions of other apps from other people. Maybe you don't care about all these other apps or all these native features. You just want to run your own app. Maybe you're an enterprise and the Google Assistant comes with consumer terms and conditions. Maybe that's not what you want. Besides that, the Google Assistant also has a set of specific technical requirements, such as that the microphone can only be open for an X amount of seconds. Maybe you want to keep the microphone open for a much longer time. So there are lots of reasons why you could build your own voice AI. And some of these use cases that could be like self-service kiosks. These are the machines that you see on airports and in train stations, for example, to order tickets from. And you can maybe use that by using your own voice. These can be devices with custom hardware. Maybe you are a developer and you have a Raspberry Pi and you want to do some fun stuff with your own voice commands. That could be. Car navigation systems. They use voice, spoken voice, and they return voice to you. It's also custom. It's not, you don't need to talk to Google first. Smartwatches, maybe a custom voice in websites to browse to certain pages without using actually your mouse or keyboard. And the last use case, these are in the contact centers where robots, for example, could pick up the phone and handle the whole conversation for you. And you can do that, for example, like when it's very busy in the contact center and you don't have the people to pick up all these phones because the waiting time and the hold times are so long. So you automate this by having robots picking up the phones, and they sound very human-like. These are all reasons where you could use custom voice AIs for. There is a big difference between the way how the Google Assistant works versus creating your own voice AI. And that is that the Google Assistant mostly works with short utterances. So that means like you will say a simple sentence. I can say like, hey Google, turn off the lights. Okay, then the AI can quickly understand what the intent is, because the intent here is to turn off lights. But when you have a custom AI, for example, in a contact center, people can start with whole books of stories. Like, yesterday I forgot to pay my bill, but then my husband said, like, well, you can wait a couple of days. The next day I was sick. Now I don't know what to do. Like, it's sometimes even difficult for a human to figure out, like, what is the intent? What question do I need to answer? Now imagine how that is for a machine. Like, there are so many sentences being said. What's the sentence that I need to answer on and return? So that means like these are long utterances. It keeps polling for incoming voice and returns the voice. Now, for my app demo, I'm using a set of tools. I'm using the browser's microphone, and I'll use WebRTC in this case, so I can capture an audio stream, and I'm sending this stream to a backend. And in the backend, I will use this audio stream to talk to certain Google APIs. And in my case, this will be speech APIs, from speech to text. Then I have written text. From there, I might want to translate it to a different language. And then I'm going to detect the intent with Dialogflow. And once I finally got the response, then I return it with text to speech, so I get back an audio buffer, and then I will play that back in the browser. So it's kind of tricky to do this, but I'll show you today how to. All right, let's have a look into my demo. This is a demo of a self-service kiosk, like a fake one, of course. And imagine that, you have an airport, and at the airport you can ask questions by using your voice. Actually, now in the Corona time, this is actually will be a great use case because people don't want to touch or like other like keyboards and so, because other people are all touching it. So by using your voice, that will be a great use case. In this example, you can see I can start the application, and then I can start asking questions, and it will return some answers on the screen, such as what time is boarding?
Passport and security checks and boarding can take longer than expected. Per airport, these times may also vary. To prevent delays, we ask that you arrive at both the airport and the gate on time, especially during the busy holiday travel seasons.
Can I take a lighter in my hand baggage?
Small lighters and safety matches are only allowed if they are worn on your person, not as hand luggage. Carry them with you in your jacket or pocket.
Now, actually, I have another feature built in, and I could also use my own native language, and then it translates it back in my native language. So I'm going to set now the machine to Dutch. I'm going to ask a similar question. Hoe laat moet ik bij de gate zijn?
Paspoort- en veiligheidscontroles en instappen kunnen langer duren dan verwacht. Ook per luchthaven kunnen deze tijden verschillen. Om vertragingen te voorkomen, vragen we je om op tijd op de luchthaven en bij de gate te arriveren, vooral tijdens de drukke vakantiereizen.
Now, and what's so special about this is like the Dutch version is not built into Dialogflow. It's just translated on the fly, and it sounds perfect Dutch to me. Now, so how did I build this? Like with all problems, once you face problems, if your problem isn't already on Stack Overflow, you're either a genius or a dumbass. And the problem that I had was like my problem wasn't on Stack Overflow. And I figured like, no, I'm not a dumbass. It's just like super difficult to do, build a flow like this, because you have your audio stream in the browser, and then you need to talk to technology that's all running on server side. And like with many problems, it's always the case. It's like it's not just talking to Dialogflow or talking to a speech API that's difficult, or setting up a stream in a browser. It's like the combination of all the tools all together. And that's what makes it difficult. But I found a solution, and I've created the best practice for this. And it starts by creating a front-end app. And in my case, as you've seen, it was an Angular app, where the user records their voice with the browser microphone, and then eventually, after the results come back, it will return audio back into the browser app. The first problem that I faced was, how will the microphone work across all browsers? Because I figured out like, oh, it works great on my Mac, and it didn't really work great on iOS devices, and also in Internet Explorer it had some quirks. So I needed to come up with a solution for that. Also, I had to make sure that the audio, the stream that will be like handled, how will that be treated in the backend? Like I think on the front end it was an audio buffer, and I don't think Node.js, because that's what my server always looked like, couldn't handle that right away. So the first problem that I solved was actually by just using somebody else's great work. I found a library online which is called RecordRTC. It's based on WebRTC, and it's just a library for audio and video and screen activity recording. It's open source, so that's great. And how that looked like is kind of like this. In my Angular app, I created a class, and in this class I am I'm loading the RecordRTC library. So like first on start, so once you start the application, it runs navigator.getUserMedia. That's the method, the WebRTC HTML5 method that's built in your browser. But I'm using the RecordRTC, and by using the RecordRTC library, I could make sure that it works across all browsers the same way. Now, the tricky thing is you need to set this up, and so it's very important that when you set a sample rate, that the sample rate should be also the same once you code the server-side implementation. So my recorder type, I set that to stereo audio recorder, even though on the backend I only can handle mono audio streams. But the great thing about this library is once you use a stereo audio recorder object, you can set the number of audio channels. So I could set it back to 1 again. That's what I did there. I need to set a time slice because I'm working with streams. What I'm doing here is actually I'm I'm creating chunks of my stream, and those little chunks, that's what I'm sending to the backend. And I set it on 5 seconds. So that's just enough for filling in a simple sentence, and then it will continue by going on. I set the desired sample rate, I downsized it, just so that the stream, by sending the streams, those are nice and small, so my application performs faster. Right. Then, yeah, of course, I'm talking to my backend application. And yeah, the next question was like, well, how would I stream this from the front end to the backend? And how can I deal with bidirectional data? And what I did here was I was making use of Socket.io. Socket.io is actually in real-time bidirectional event-based communication, and I use an extra module on top of that, which is called Socket.io Stream, and that's great for binary stream transfers because like I could stream both ways. Yeah, so I can just install that on my Node application. So what I'm doing here is as soon as the data is available, I am sending the binary stream. In my Angular app, it's in my service, so I'm sending this binary stream to the backend, which is what you can find here. Send the binary stream, and this is the Socket.io stream implementation where I stream this to the backend. I do give it a name. That's just so for I send some metadata and a size, and then the target language. The target language is because, as you have seen in my demo, where I was switching the flags, yeah, it's nice to know like which flag was actually selected. So that will be the target language later on. Then, I mean, what I need to do is I have this stream, of course, and I need to take this stream and make text version out of it. And this is something I could do really great with the Google Speech to Text API. It takes audio streams or audio files and it converts it to text. This API recognizes over 120 different languages. So it even, I mean, I even don't need to set the base language. It recognizes it recognizes which language it is, and then it puts it into a text variant. Yeah, so here you can see the speech implementation in my Node.js code. Here I am, first I'm setting up a speech-to-text request. And now this is again important. I need to make sure that my sample rate is the same as the sample rate that I'm using in the front end. In my case, this one comes out of an environment file, but I made sure it's the same. Then I need to set the encoding. The encoding that I set that in the environment file as well. Let me just open it so I can show you what I've done. So you see here the sample rate is 16,000. Again, this was the downsized sample rate, right? So not the one from the browser, but the one that I downsized it to because the stream was smaller. And here is the encoding setting. This is a setting that's based on the Speech API. If you go to the Speech API documentation, you can choose like from a bunch of options, and this is basically like a wave file. Yeah. So I create that object. I can say the microphone distance is near field because the microphone will be close to the screen. And I'm having enhanced, like advanced machine learning models that I'm using, and I'm enabling automatic punctuation so that it also can automatically makes ends of sentences for me. And then I can make the call. Now in my case, it's not a simple speech to text call, it's a speech streaming to text call. So I take the stream that I received from the front end via Socket.io stream. I know the language, and then I have a callback function which will be executed once it's done. And this is actually the magic. Here I say streaming recognize, and I pass in the speech request, and then as soon as data comes in, yeah, it returns the results. And this is just the text what's been said. And as you can recall from my demo, you saw this in the waveform. You saw the phrase that was being said, it's being captured. So then we have an architecture like this. Now we need to pass it to Dialogflow because we want to figure out what the intent is. Like, we want to detect what actually is happening here. And Dialogflow, that's actually a development suite for building conversational UIs. So people usually build this for building chatbots. It was formerly known as API.ai, but got acquired by Google in 2016. And now there's like a whole Google Cloud team working on it. And the way how Dialogflow works is based on machine learning. So it does natural language understanding. We understand what's being said, and we can match that to a certain intent classification. And the way how it works is in Dialogflow. This is what you see. This is Dialogflow. It's a UI interface, but as you will see later on, like, also comes with an SDK. And in Dialogflow, it works based on intents. So I can create like a list of all different flows, like conversation parts. And such a conversation part needs to have training phrases because I'm training a model in this case. So when I have a question like, what time is boarding? Yeah, I could say like, what time is boarding? What time should I board? At what time should I be at the gate? Like, these are all different ways of asking basically the same thing. And once a user says their utterance in the browser app, what Dialogflow will do is it will get the text. I mean, we have now the text version, as you've seen, and it will basically look in the model and figure out like which of all the intents is the right one, and that one will return the answer. And then the answer could be either in hard-coded in text. In my case, I'm returning also a custom payload because I want to show the question and the answer nicely on the screen. But let's say that I would connect it to a backend system, to a different database. Yeah, then I could enable fulfillment, and I say like, well, the answer actually comes out of a webhook. Dialogflow also works with entities. So these are like objects where you can take action on. For example, I created an object airlines, and then like these are all the key value pairs for airlines. So it's basically a variable. So if I would have an intent like what gate is KLM, then KLM is the variable part. It could be Flybe, or it could be Corendon Airlines or EasyJet. Doesn't matter. Like we capture the parameter and figure it out. And we can even work with synonyms if we want to. Like, we can just specify them here. Yeah. Now I did something else in my demo app. I also make use of knowledge bases. Actually, what I'm doing is just I'm importing like a certain airport FAQs from websites. So if I would go to the Dutch airport, they have an FAQ page, and I'm just loading all the questions and answers in. So now I could also ask one of these questions in my app, and yeah, it will return the answer. So that's really great. Now, what we will do is we have this text version, and we will send the text to Dialogflow to do the intent matching. And actually, I did like some extra steps here, as you've seen in my last part of the demo, where I also use translate. Because like, as you have seen in Dialogflow, I only am storing the English version of all the answers and questions. But what if people speak Dutch or Chinese or German? Yeah, then they can just use their native language, and they will also hear German audio or Chinese audio. But Dialogflow detects it based on English language. So I'm gonna show you the implementations of these two. First, the translate. I'm setting up a translate. Again, this is on a Node.js backend. I created a class translate where I create a translation client. This is the Google Translate API. I am pointing to a Google Cloud project where the Translate API is enabled. And again, a Translate API can detect automatically the text, the base language of the text, although I could set it as well. And I'm setting the target lang. And again, as you can recall from my previous examples, I'm setting the target lang in the front end and once you select a flag. And then the whole magic here is like on the translation client, you run .translate.text and you pass in the full request. And then it returns you a translated version of the text. Yeah. In my case, this means then, like, let's say I spoke Dutch, so it took the Dutch version of the text. The text I have, I have the spoken text written out, and I'm passing it to translate it back to English, and then I'm returning the English phrase. And the English phrase, this is what I pass into Dialogflow, because then Dialogflow can do the text. So if I open Dialogflow right now, the Node.js class for my Dialogflow implementation, it's here. I'm doing basically the same thing again, like I'm creating a class, I'm defining my project idea and the language code, and in my case this is English, and I'm setting up the Dialogflow agent. I need to create a session idea because every session, every conversation that I have with the agent should be unique. So I create a session client, and from the session client you need to create a session path, which basically contains the project idea to make sure like which agent in Dialogflow is it, and then the session idea to make it unique. And then I create the request where I say, like in my case this is a query input based on text, and I'm using the language code that I'm using. And then the whole magic here is to run a detect intent. So on the request query input text, you specify the translated text. So in my case, the English text. And here I have like a promise where it says like on the session client, I run detect intent with my request as input, and then I get responses back. And the responses, yeah, in my case, as you can recall from my Dialogflow interface, I had like a custom payload where I get like the full object out. So I have the question and the answer, and I can return that. Then I do run it again back to the Translate API to translate it back to Dutch. And that's the part that eventually need to be spoken out. Here you see the architecture. And once I have the translated voice, so in my case Dutch, I need to speak it out, and I'm using the synthesizer for this. So I'm using Cloud's text-to-speech. Now, to synthesize the text, we will make use of WaveNet technology, and Google has an API for that as well, which is called the text-to-speech API. And this API makes the voices or the sound very human-like, and you can even control the pitch and the pace and the pauses if you want. And I am doing this again in my speech class. I wrote both. I can create first a text-to-speech object where I design a voice. I can say like it's maybe in my case I think it was a male voice, and I need to set the audio encoding again based on the options from the text-to-speech API. And again, like it's probably linear 16 because that's nice in the browser. I don't want to encode it because then I need to work with converters. I could if I want to keep it smaller, but I didn't do that. Yeah, then I'm sending it to the text-to-speech API where I take the input text. And then here's the magic. I run synthesize speech with the input as a text, and then I get an audio object back, an audio buffer back. And now this audio object needs to be returned to the browser. That's again a tricky thing, because how will I be sure that it will play in every browser? I figured already that iOS was doing a buggy with that. That is because a user need to accept it via the user interface before you can play something, because they don't want on phones that you can just bomb people with audio. So you need to, as a user, need to accept it first. So I did do some quirks there with resuming and pausing it. But I got it to work. And the thing was, I had to go back into my Angular app. And here what I did is I created, and this is again a native WebRTC from the HTML5, so in the browser. You create an audio context. And I did some other things here as well. I created like an analyzer and a visualizer to show also the waveform nicely on the screen. But the way how this basically works is you need to assign it to a source, and a source that could be your computer speakers. And you create a source, and then you pass in the stream that you get from the server, and then you connect to it. Yeah. And again, I need to do some quirks here by stop and starting it, resume and starting it, to make sure that it also works on iOS. All right, so first I had it running on localhost while I was developing it. And when you run it on localhost, I think the only thing you need to do is like you get like a pop-up in the browser where you need to accept and allow your browser to record the microphone and play audio. But when you want to run a solution like this in a cloud, you need to be sure that you run on HTTPS. So you need an SSL certificate. In my case, this was very easy because I was using Google Cloud, so I could make use of App Engine Flex. And App Engine Flex can automatically set up SSL certificates for you, free. And that's easy. So it's just a deploy command on the command line. And then it basically creates a container for you. And with that container, the container will be deployed. Now, if you think like, wow, this is really cool, I would like to play around with this myself. Yeah, you can do so because I open sourced my code. It's on GitHub. You can just clone the repository. If you have some suggestions, yeah, feel free to create some pull requests. I'm happy to browse through it and get your feedback. Thank you so much for watching this video today. Also, my slides and all materials in block form are available from the GitHub repository. So enjoy.
So Lee, thank you very much for the presentation. As I can see, Slide has been active or starting to be active when people can put their thoughts together and assimilate everything they heard. Thank you for being here today for the presentation.
Yeah, of course, I'm happy to.
I'm gonna share my screen so we can look at the questions together.
Yeah, let's do that.
Perfect. So we have first, it's a comment. Whoa, that's really nice. This was actually submitted quite early in the presentation.
Yeah, I saw that one coming by. Yeah. But yeah, thanks. I think it is really nice. I mean, and it's also, once you know how to do it, it's actually very easy. It's just like a Lego block stacking on top of each other. I mean, it's just what made it difficult was, figuring out the right way how to combine it all together. But once you know that, then it's just like the implementation that was really awesome.
Good.
Yeah.
Then we have Mike. I must say, Mike has been a really active member in our live week, as well as Tom, whose comment we just saw. And I think this will be the last comments they're gonna have for this week. I think I'm gonna miss them during my weekend. Where do you see chatbots going to the next 12 months? Will the implementation be faster because of COVID-19? Yeah.
And I saw that there's another question kind of similar about COVID. So I think I can answer it both in once.
Yeah.
So here, like the whole COVID experience, of course, is bad. But if we look into technology, I see that it's like chatbots, they get a lot of traction. And like in, for example, the self-service kiosk that I built as a demo, that would be a use case that there are now lots of businesses are looking into, because like, yeah, first of all, when you're at an airport, you don't want to touch the keyboard that everybody else is touching. So those types of scenarios, those are becoming more and more important. But it's also in contact centers, and I think we all have like experience in that you call, for example, an airline nowadays because your flight got canceled, or maybe you need to do a call to a government instance or a healthcare provider. Like they all have like 45 minutes to an hour waiting time.
Yeah.
That wasn't the case in the past, but now it is, and think about it, like how you can solve this by having robots picking up the phone, and the robot that sounds very human like, so it doesn't really sound very robotic, so people will also treat it as a human because it sounds human like. And like in the scenario of an airline, like where are most people calling for? Well, flights are canceled, so people are like in stress, like what should we do now? Or they're stuck on an airport, and how will I go back home? If you only implement those two questions in Dialogflow and you train your model on a scenario like that, then I think you probably can handle 80% of the load of the contact center by answering that question via the robot. And then it keeps your contact center nice and clean, so that real humans can take over the phone call and give real personal help. And then there is no phone, no waiting line anymore or hold time. So I think that's a scenario we see at Google a lot now, that businesses want to implement that. And we help these businesses also with that, because we have like predefined models already that we can just hand them out and say like, well, here is a COVID-19 model. You can just implement this in your contact center with the existing contact center provider that you already have.
Yeah, and I think people would be happy on top of this for this solution because of the annoying elevator musics that they usually put while you wait for 1 hour.
Yeah.
Good, thank you for the answer. Next is it's more of a comment. Really nice how you switch between the process and the code. Thanks for the presentation.
Thank you.
Really nice feedback. Dialogflow is really awesome too. Another supporter.
I think so too. And the reason why is because, like, you see, I'm a developer, so I love working with the SDK, and Dialogflow comes in all flavors, so I can use any language that I want, if it's Python or Node or Java or C. I can use that. But same time, also conversational UX designers, people that are not developers or programmers, they can also use the tool through the web interface. And yeah, that's when I look to companies that I worked with in the past, I really saw this division in, like, sometimes the business was working with Dialogflow, and then you had the developers working on the implementation, versus sometimes there were no developers at all. So it's really, really an awesome tool.
Good. So you would recommend it for more people for sure too.
Totally. No, but actually Dialogflow, I think, is one of the most popular tools in chatbot scene. We have over 1.5 million developers using it.
Wow.
So that's a lot.
It's popular for sure.
It's very popular, yeah.
Yeah, this was actually the other questions we had for Corona, so I'm gonna skip it. How do you think people need? Do you think people need more emotions in those hard days, and bots are harder to have them?
Yeah, it works both ways, Like, I mean, I spoke with a person who works in a hospital, and she said, like, yeah, we're thinking about implementing robots in a contact center, but yeah, like then the conversation is maybe, I mean, less emotions. Maybe that's not what you want. That's true, but then you can still filter out all the not so emotional covered questions and answer the robot those questions, so you can keep the people in the contact center free for having, like, the more personal talks. On the other hand, I worked with finances in the past, where people had payment delays and they want people to pay, so they had robots reaching out to people to tell them like, yeah, you need to pay your payment. What they have seen, like in the past, like when a real human would call, then humans will not pick up the phone because they're in debt, they are ashamed, so they don't pick up the phone, or they pick up the phone and they have like whole excuse like, yeah, my mother was sick and then the dog got run away, blah blah blah. When you have a robot, the robot has no emotion, so it's like, well, I don't understand, but please pay. So it works both ways.
Yeah, I guess for the companies, then it's much more useful.
Yeah, and it depends on the scenario, of course.
Good. How would Twilio fit into your workflow?
Oh, that's a good question. So in my application, I'm not using Twilio. I'm building the whole speech-to-text. I'm integrating all the speech-to-text from Google myself. And also as part of Dialogflow, I could also just use the speech-to-text built in Dialogflow. But we are working together with Twilio for the contact center solution, together with all the other telephony partners such as Genesys, Avaya, Cisco, etc. And when you want to have a contact center solution, then typically customers will go to a telephony partner like Twilio and ask them like, hey, can you enable the robots in my contact center? And then they will enable, in fact, it is Dialogflow under the hood. So you can train your own model. But we do work together with parties like that.
Okay, thank you very much for the detailed answer. Just curious, why do you use STT and TTS when Dialogflow supports audio query and speech?
Yeah, good question. I'll tell you why. Because in my scenario, I wanted to translate the contents. So actually, I'm using in Dialogflow a knowledge base where I'm fetching all knowledge articles from websites, and those are only English websites that I'm importing. Now, I mean, I also wanted to support Dutch and Chinese, and I don't speak all these languages. So I'm using Google Translate to translate it. But to translate it, I need to have access to the speech myself before it goes into Dialogflow. So that was the reason, like I would say, like if you want to modify the incoming speech before you send it to Dialogflow, then it's a nice solution to make separate calls to each. I can imagine like maybe a more real life scenario, like let's say you're working at a bank and you want to make sure that all sensitive information got removed before we send it to the cloud. That's also a solution. Then you first you get the speech yourself, and then you scrap out the stuff you don't want to send or store in a database, and then to Dialogflow. So then you use Dialogflow for text intents. But it is correct what you're saying. You can use Dialogflow with built-in speech and built-in speech output. It works really well under the hood. It's making use of the same models, the same APIs, but it's probably cheaper because you're talking to one API instead of 3. And technically speaking, it should be faster because you're connecting to one API, although I don't think that really matters because it's both on the Google Cloud Network, and once you're making use of Google Cloud components, the Google Cloud Network is like over 10 times faster than normal internet. So latency-wise, I think it should be fine. Just talking a little bit about latency, because maybe you noticed in my demo, there was like a little bit of a delay before the answer came back. That's actually not part of the APIs. That is actually built in on purpose, because what I want to do is I want to send chunks of data to Dialogflow and or to the speech to text. And I don't want Dialogflow to start detecting right away on one word. No, I want it to have like enough context that it would find a result. So I waited like I think 5 seconds or 4 seconds till it gathered enough content before sending it, and I'll do that. I was streaming it, but in chunks.
Okay, thank you so much for
the
explanation. A question that has been, I think, there since the rise of chatbots.
Yeah, I get that question all the time. Chatbots taking over people's jobs, and what do you think about it? Now if you think about the contact center solutions, where robots pick up the phone, they do pick up they do take away people jobs. Is that a bad thing? Not necessary. Like I don't think. Like I still think that we still need humans at contact centers or at other tasks that robots are there, but the human can provide much better emotional or personal help than a robot can do, and especially when we're talking about contact centers, they're like I spoke with the CEO of the Dutch Contact Center Federation, and she told me like, yeah, it's actually contact center work is actually a very stressful work because first of all, like these people that are in the contact center always have to answer the same question like millions of times a day because everybody always calls for the same. Think about you work for a healthcare provider, people are asking, oh, am I insured for this? What about that? Am I also insured for that? So that's always the same question that you need to answer. They often need to look in all kinds of systems, so it's also very stressful and repeating work. And then, like, I know how I am. Like, if people are unhappy on the phone, then they start to get angry. So it's also not really the most. I mean, it's not the nicest work to hear so many people being angry at you all day. So people get stressed a lot in contact centers. And just to have robots helping with conversations or robots in a contact center listen in and supply suggestions on the screen for the human agent, those are huge benefits. So I think robots and people go hand in hand, and that's a good thing.
Yeah. It's for sure not an easy job on that side, and it's rarely that people call to say thank you or you have a great service or give this positive feedback. So you call with a complaint.
Yes.
Unfortunately, we got one question. Can you briefly speak to implications for handicapped persons or developers?
So I guess I'm not really sure if I understand the question correctly, but I think like when we're thinking about chatbots, you can build voice chatbots as what I showed in my demo, and that's a great thing for disabled people. I mean, like I could control a website without my hands if I want to, if you implement speech technology right, and I mean, so it is like this is a huge benefit. These conversational AIs that we can implement. I actually worked a lot with businesses that are using speech to text, and text to speech together with Dialogflow in websites for that reason, to make it more accessible. So people don't need to type or use the mouse; they can just speak to it, and the website would filter a screen for you or open search results. Yeah.
Okay, thank you very much. I'm going to give a couple of more seconds for people to ask questions if they're currently typing one, because this also has happened in the
yeah.
So people also see the code and how they can go ahead if they have some thoughts. Meanwhile, also to remind you that right after we close this session, there will be a short survey about Lee's talk, so you can also give us feedback. How do you like the topic? How do you like the whole presentation? And right after, we'll have a symbolic closing ceremony here in the office. So stay tuned to see that. If not, we're gonna stay a bit more. But if not, Lee, I want to thank you very much for joining us, for participating.
Yes. And thank you everybody for joining and watching my talk. It was a great experience, and I hope to see you all live next year.
Exactly, we would have loved to have you currently in Berlin in a more normal setting.
Yes,
you're more used to, but well, good. If any questions come in meanwhile, we'll make sure we actually send them to you, so you can answer them on social media or in a blog.
Yeah, I will.
So you already, everybody, seeing the survey for the feedback. Thank you very much again for participating, for closing our event. Yes. And I hope to have you soon in some way involved again with WeAreDevelopers.
We will. Thank you so much and have a great weekend.
Thank you, you too.
Yeah, bye-bye.
Yes, so everybody, we have managed. We went through the live week. And you can see I'm here in my sparkling outfit with a glass of Prosecco to celebrate this week because it's an achievement. It's the first time that we have organized something this big, and it could not have been possible this big online actually, because usually our events have around 10,000 people. So this would have not been possible without any of you. So thank you for being so active on social media, on Slido, on Slack, on all of our channels. I also want to thank our partners, our sponsors, and all the medias that have supported us throughout the whole preparation and also during the week. The videos are recorded, so if you haven't managed to watch some talks, you will get them for sure. And with this being said, actually, I want to encourage you to subscribe to our newsletter, because this is how you can find information of what's coming up next. Updates, when the video is going to be out, if we're going to have more live sessions, is there going to be a live week again? And also there will be a survey for your full feedback for this whole week, for the whole experience, for the topics. And it's actually a survey with a giveaway, so make sure you check your emails from WeAreDevelopers soon, so you can, so you maybe win something. Good. I want to also thank you very much to our team, for the whole WeAreDevelopers team, for the ones who have been here in the studio with me the whole week and the weeks before to prepare, as well to everybody in their home offices who have been preparing this whole agenda, from the single graphics to every social media post to this whole studio experience, the whole program, the whole content, and all the logistics. Really thank you. I love the team we have. So I actually want to invite the people who are currently in the office with me to join me in this setting with a glass of champagne and confetti. Come on, confetti, we can join you already. So here is Bessie, our head of content. Thomas, our head of marketing. Claudia, our amazing office manager who has been supporting us in this. Gary, our VP events, who made this whole thing possible and will bring us together. And last but very not least, the man behind the scenes, Stefan, our head of developer experience, who has been doing this amazing job and keeping this event live on the internet. So cheers guys, congratulations for this successful first online event. And to everybody who is watching us still from home, have a good weekend, don't miss us too much, because we'll be back soon with the next WeAreDevelopers live sessions. Goodbye! Bye! And here are my graduation cards. Cheers. Cheers. Are we live still? Should I say something more?